Welcome to the Sleepy Geographer, a quiet corner where the world unfolds slowly, fact by fact, ridge by ridge. Tonight the story waiting for you is all about how mountains are born, the colossal shapes that rise where the earth decides to push against itself, slowly sculpting the skyline. Before we begin, I'd love to know, where are you listening from this evening? Perhaps you're in the shadow of mountains yourself, or maybe on a flat plain dreaming of distant peaks. If you find comfort in these journeys, I'd be so grateful if you could gently tap the like button and subscribe. To those who are already subscribed, thank you kindly. You're the steady foothills at the base of this channel's landscape, and a small reassurance. I do hope this video doesn't end up being so interesting that it keeps you awake. But if it does, at least you'll slip into tomorrow with a few new facts nestled in your mind like stones in a mountain stream. So how does the Earth, vast, restless, and unimaginably slow, raise such mighty walls against the sky? Mountains are not built in haste. They do not erupt fully formed into the horizon, but instead grow with the patience of ages. In this video, we will trace their story from the restless motion beneath the ground to the towering ridges and snow-capped summits that command so much awe today. This is not just a tale of rock and pressure, but of time itself, a drama written over millions of years where continents crash together, volcanoes pierce the crust, and glaciers carve valleys like chisels against stone. We will follow mountains from their earlier stirrings deep within the earth, through their rise to power and onward to the long, slow erosion that eventually humbles even the tallest peaks. Along the way, we will pause at mountain meadows and ridgelines, considering not only the geology but also the myths, the cultures, and the quiet influence mountains have had on human history. This journey is both scientific and reflective. It is about tectonic plates and lava, yes, but also about what mountains mean to those who gaze up at them. Symbols of permanence, challenges to climb, boundaries that separate, and sanctuaries for life. Each chapter will bring us a little closer to understanding these giants, not in a rush, but in a steady rhythm, as though walking up a gentle slope. So let us begin this climb through knowledge, one step at a time, into the story of how mountains are born. Beneath the ground we walk on lies a world of hidden drama. The earth, for all its appearance of stillness, is layered like an enormous cake, each tier with its own character and role in shaping the planet. What seems solid and immovable underfoot is actually a restless surface, drifting and bending in ways that only reveal themselves when enough time has passed. To understand mountains, and indeed much of the planet's behaviour, it helps to peer into these layers and imagine what is happening far below the soil and stone we see each day. The outermost layer is the crust, a thin skin that covers the globe. In some places it is only a handful of kilometres thick, while beneath continents it can reach a few dozen kilometres. Compared with the size of the Earth, that is remarkably delicate. If our planet was scaled down to the size of an apple, the crust would be no thicker than its peel. It is upon this fragile shell that every tree grows, every city stands, and every human story unfolds. Beneath the crust lies the mantle, a vast domain of rock so hot that it flows, though at a speed that makes even a snail look hurried. This slow, creeping motion is known as convection, and it is the engine that drives the continents across the globe. The mantle is not molten in the way a pot of soup is, but over immense timescales it moves like a thick paste, circulating heat from the deep interior toward the surface. Though invisible to us, these great subterranean currents are the reason mountain ranges exist at all. Deeper still, we encounter the core. This is divided into two parts: the outer core, which is liquid iron and nickel swirling constantly, and the inner core, a solid sphere of metal compressed to incredible density. Temperatures here soar to levels that would melt any material we could imagine, hotter even than the surface of the sun. The churning of the outer core generates the Earth's magnetic field, a shield that deflects harmful solar winds and allows life to thrive on the surface. Without this hidden dynamo, our planet would be a very different place, perhaps lifeless altogether. It is the relationship between the brittle crust and the flowing mantle beneath that sets the stage for mountains. The crust is not a single unbroken piece, but rather a patchwork of enormous plates. Imagine a cracked eggshell, the fragments slowly drifting on the softer layer below. These tectonic plates shuffle about at a rate of only a few centimetres per year, comparable to how quickly your fingernails grow. Yet when you multiply that movement across millions of years, the results are profound. Oceans open, continents collide, and new landscapes are born. The idea that the ground itself moves was once seen as outrageous. For centuries, scholars imagined mountains as wrinkles that appeared as the earth cooled, or as mysterious accidents of nature. It was only in the 20th century that the theory of plate tectonics brought the evidence together. Fossils of the same species were discovered on continents now separated by vast oceans. Coastlines across the Atlantic seemed to fit together like puzzle pieces. Seafloor surveys revealed ridges running for thousands of kilometres where fresh crust was being created. All these clues pointed to a single conclusion. The surface of our planet is mobile. Where these plates interact, the real drama unfolds. At some boundaries, plates grind past one another, triggering earthquakes. At others, one plate dives beneath its neighbour, creating volcanoes and deep ocean trenches. But perhaps the most spectacular events occur where two plates meet head-on. If one is oceanic and dense, it usually sinks beneath the other. If both are continental, neither will yield. Instead, they crumple and fold, forcing the land upwards into towering ranges. Mountains, then, are the surface's response to the slow but unstoppable drift of these immense slabs of crust. Consider the Himalayas. They exist because the Indian plate has spent the last 50 million years drifting northwards, colliding with the vast Eurasian plate. Neither continent could sink beneath the other, so the crust was squeezed upward into a chain of peaks that remain the highest on Earth. Even now, the collision continues, raising Everest by a few millimetres each year. The Himalayas remind us that mountains are not fixed monuments but works in progress, still under construction by the forces beneath our feet. Yet it is not only collisions that build mountains. In the middle of oceans, plates pull apart, creating rift zones where magma rises to fill the gap, hardening into new crust. Over time, this process produces immense undersea ridges, the longest mountain chains on the planet, though they remain hidden beneath the waves. These ranges stretch for tens of thousands of kilometres, proof that mountain building is not confined to continental collisions, but occurs wherever the Earth's surface is forced to move. The timescales involved are staggering. A plate may take 100 million years to cross an ocean basin. A mountain range may rise over tens of millions of years, only to be eroded away in the next 100 million. To human eyes, such changes are imperceptible. We may experience an earthquake that shifts the land suddenly, or witness a volcanic eruption that builds a new cone overnight. But these are flickers in a much grander story. Most of the Earth's reshaping happens so slowly that it can only be seen in hindsight, when valleys and ridges reveal what has been taking place all along. And yet, despite its slow pace, the process is relentless. The continents will not stop their drift. Oceans will continue to open and close. Mountains will keep rising and falling in an endless cycle. This is the restless Earth beneath our feet, a planet that appears still but is always on the move, shaping landscapes that seem eternal but are in fact temporary. Every peak, every plain, and every coastline is the product of this ceaseless motion, a reminder that our world is never finished, only changing form. When two continents draw close, the Earth sets the stage for one of its greatest dramas. It is not an explosive meeting, not a sudden crash, but a slow-motion collision played out over tens of millions of years. Unlike oceanic crust, which tends to sink back into the mantle when it meets a continent, continental crust is light and buoyant. Neither side is willing to dive beneath the other. Instead, when continents converge, Their edges buckle, fold, and stack, producing mountain chains of staggering scale. These are fold mountains, landscapes written in stone by the patient violence of plates pressing together. The Himalayas are perhaps the clearest example. Around 50 million years ago, the Indian plate was an isolated landmass drifting steadily northward across the ancient Tethys Ocean. When that ocean finally closed, India slammed into the southern margin of Eurasia. But because both land masses were composed of relatively low-density crust, neither could sink. The only option was to crumple. Layers of rock that once lay flat at the bottom of the ocean were thrust skyward, piling into ridges and peaks. Fossilized seashells and corals formed in warm, shallow waters now rest thousands of meters above sea level on Himalayan summits. Even today, the collision has not finished. India continues to push north at a rate of several centimeters each year, forcing the Himalayas to rise ever higher. Mount Everest, the tallest point on Earth, gains height with each passing century, though erosion also works tirelessly to bring it down. Earthquakes frequently ripple through the region as the immense pressure between plates is released. Far from being ancient relics, the Himalayas are a living system, caught in the act of formation. If the Himalayas are the Earth's tallest expression of continental collision, the Alps are its most elegant. Their story began when the African plate began drifting northward, pressing into Europe. Between them lay the remains of the Tethys Ocean, its sediments accumulating over countless ages. As Africa advanced, these sediments were caught between the converging continents, crumpling and thrusting upward into an arc of peaks that stretches across the heart of Europe. Unlike the Himalayas, which are stark and extreme, the Alps show their age in more varied forms. Jagged ridges soar above green valleys, glaciers drape themselves across high passes, and foothills roll outward into farmland. But the underlying structure is no less dramatic than Asia's giants. The Alps are a geological knot where layers have been folded, overturned and stacked upon one another in a bewildering complexity. The snow-topped peaks visible today are only the surface traces of a deep and tangled history of collision. What makes fold mountains fascinating is the way they preserve the memory of their birth. Walk along a ridge in the Himalayas or the Alps, and you may see layers of rock that were once horizontal now standing on end, or even folded back upon themselves. Some layers have been thrust dozens of kilometers over others, as though the crust were a vast carpet shoved across a floor and bunched into ridges. The forces required to produce such features are difficult to imagine, but their results stand all around, towering reminders of the power of slow compression. Continental collisions are not gentle. As the crust is squeezed, earthquakes ripple outward, reshaping the land in moments. Entire river systems can be rerouted, and valleys can be dammed into lakes by the sudden uplift. Over time, vast plateaus are raised, such as the Tibetan Plateau north of the Himalayas, which sits at an average elevation of over 4,000 meters. This plateau, the largest and highest on Earth, influences climate patterns across Asia, helping to generate the monsoons that billions of people depend upon. In this way, the consequences of continental collisions extend far beyond the ranges themselves, shaping weather and life across continents. Nor are fold mountains static once raised. As soon as peaks are lifted skyward, erosion begins its steady counterattack. Rivers carve deep gorges, glaciers slice valleys, and frost shatters expose cliffs. The sharp edges of young fold mountains gradually soften, though the pace of erosion depends on climate and elevation. The Alps, for instance, are older than the Himalayas and have already been worn into gentler shapes in many places, though they remain imposing. The Himalayas, still in their youth, are raw and dramatic, with steep walls and unclimbed summits. Despite their vast scale, fold mountains also reveal the fragility of stone. Rock, when subjected to the weight of continents colliding, can bend like clay. Under immense pressure and heat, once rigid layers flow, twist and ripple. In the Himalayas, Beds of limestone and shale have been folded into graceful arcs, as though the earth itself were sketching waves upon stone. These folds, frozen in place, are geological records of stress, reminders that even the hardest materials yield under enough time and force. Human history too has been profoundly influenced by these mountain chains. The Alps have acted as both barriers and crossroads, shaping the course of trade, warfare and culture in Europe. The Himalayas have stood as formidable walls, influencing migration, religion and settlement. Many cultures have looked to these towering peaks as sacred, interpreting their creation as the work of gods rather than the slow press of tectonic plates. And in a sense, the awe they inspire is fitting. The true explanation is no less extraordinary than myth. One of the most compelling aspects of fold mountains is the contrast between their creation and their appearance. They are born of collisions that are anything but peaceful, yet when we see them from afar they seem serene, timeless, even eternal. Snow rests quietly on their summits, forests climb their slopes, and clouds drift lazily across their ridges. The violence of their birth is hidden in the folds and thrusts of their rocks, waiting to be read by those who know the language of geology. Every fold mountain is a reminder of the Earth's restlessness. They do not exist by chance, but are the inevitable result of continents in motion. Given enough time, plates will drift together, and where they meet, mountains will rise. Their peaks may seem eternal, but they are in fact temporary, destined to be worn down even as new ones are born elsewhere. To stand in the Himalayas or the Alps is to witness a moment in that endless cycle, a frozen instant in a story that spans hundreds of millions of years. The drama of colliding continents is written across these landscapes in lines of stone, arcs of peaks, and valleys carved between them. Fold mountains are the grand theatres of geology, places where the patient motion of the earth reveals itself in the most spectacular of forms. They are proof that even when moving at only the speed of growing fingernails, continents can create wonders that touch the sky. Some mountains are born not from the slow press of continents colliding, but from the Earth's fiery interior forcing its way to the surface. These are volcanic mountains, built layer by layer from eruptions of molten rock, ash, and gas. They may take thousands of years to rise, or they may appear almost overnight, reshaping entire landscapes in a single dramatic event. Unlike fold mountains, which are created by compression and crumpling, volcanic peaks are the surface expressions of heat, pressure, and restlessness from far below. At the heart of every volcano lies magma, molten rock stored beneath the crust, hotter than anything we could stand near and under pressure that demands release. When cracks form or tectonic forces create weaknesses in the crust, that magma finds a path upward. On reaching the surface, it erupts as lava, ash, and volcanic gases. Each eruption leaves behind new layers, gradually piling up into peaks. Some volcanoes grow into steep cones, others spread wide and low, but all of them carry the unmistakable signature of fire from within. Not all volcanic mountains share the same origin. Many form along subduction zones, where one tectonic plate slides beneath another. As the descending plate sinks into the mantle, water and other materials lower the melting point of the surrounding rock, producing magma that rises to the surface. This process generates chains of volcanoes known as volcanic arcs. Other volcanoes form far from plate boundaries, above mantle hotspots, regions where plumes of unusually hot rock well up from deep within the earth. These hotspots melt the crust above, creating volcanoes even in the middle of otherwise stable plates. The Andes in South America are one of the most dramatic volcanic mountain ranges formed at a subduction zone. For thousands of kilometers, the Nazca Plate dives beneath the South American plate, feeding magma into the crust. Towering peaks like Cotopaxi in Ecuador and Ojos del Salado on the Chile-Argentina border rise as a result of this ongoing process. These mountains are giants not only in height but also in activity. Many of them are still alive with eruptions, their snow-covered summits concealing fiery interiors that remind us the Andes are mountains in the making, not relics of the past. North America's Cascade Range offers a different but equally striking example. Here, the Juan de Fuca Plate subducts beneath the North American plate, giving rise to a string of volcanoes stretching through Washington, Oregon, and Northern California. The Cascades include some of the continent's most iconic peaks, like Mount Rainier, Mount Hood, and Mount St. Helens. When Mount St. Helens erupted in 1980, it demonstrated just how powerful and transformative these volcanoes can be. A whole section of the mountain collapsed, forests were flattened for kilometers around, and ash circled the globe. Today, the mountain is rebuilding itself, a reminder that volcanic mountains are never static. They are landscapes in constant flux. Across the Pacific, the islands of Japan stand as a textbook case of volcanic arcs, born of complex plate interactions. Japan lies at the meeting point of several tectonic plates, including the Pacific and Philippine sea plates, which dive beneath Eurasia. The result is a chain of volcanic mountains spread across the archipelago. Mount Fuji, with its elegant cone, has become a national symbol, admired for its beauty, but also recognized as a living volcano. Its symmetry hides centuries of eruptions, each one layering new rock upon the mountain. Beyond Fuji, dozens of other volcanoes mark the islands, shaping both the land and the culture of Japan. Hotspots, though less tied to the edges of plates, have created some of the world's most remarkable volcanic mountains. The Hawaiian Islands are the clearest example. As the Pacific Plate drifts across a stationary plume of hot mantle, new volcanoes rise from the ocean floor, forming islands one after another. The largest, Mauna Loa, is the single biggest mountain on Earth. If measured from its base on the ocean floor to its summit, it is taller than Everest. These shield volcanoes are built from countless flows of lava, spreading wide and shallow compared to the steep cones of subduction zone volcanoes. Over time, as the plate moves on, the older islands erode while new ones form, leaving a trail across the Pacific that maps the plate's journey over millions of years. Volcanic mountains are remarkable not only for their formation, but also for their dual nature. They are destructive and creative in equal measure. Eruptions can devastate landscapes, burying valleys in lava or covering entire regions in ash. Yet those same eruptions enrich the soil with minerals, making volcanic slopes some of the most fertile farmland on Earth. Vineyards thrive on the flanks of Mount Etna in Italy. Rice fields cling to the fertile ash-rich soils around Mount Merapi in Indonesia. The cycle of eruption and renewal means that human life has often flourished in the shadow of volcanoes, despite the risks. Volcanoes also connect the surface to the deep earth in a way few other features can. When they erupt, they bring with them not only lava but also gases and minerals that reveal the chemistry of the mantle. They release carbon dioxide, sulfur dioxide, and water vapor, altering the atmosphere and, in large eruptions, even the climate. The eruption of Tambora in 1815 was so immense that it caused the year without a summer, disrupting weather across the northern hemisphere and leading to crop failures and famine. Volcanic mountains are therefore not only local features, but global players, influencing ecosystems, climate, and human history alike. The presence of volcanoes has also shaped culture, myth, and imagination. Many have been revered as sacred places: Mount Fuji in Japan, Mount Etna in Sicily, Mount Olympus in Greece before science revealed its true form. In myths, they have been seen as homes of gods, gates to the underworld, or symbols of power and destruction. In science, they are windows into processes normally hidden from view, clues that help us understand how the Earth works from the inside out. And yet, for all their drama, many volcanic mountains spend most of their time in silence. They rest, cloaked in snow, forests, or meadows, their explosive potential hidden beneath a calm exterior. Their shapes may dominate skylines, their cones perfect against the horizon, but they are not frozen monuments. They are dynamic, restless, and alive, their futures uncertain, their histories written in layers of lava and ash. From the fiery ridges of the Andes to the icy cones of the Cascades, from the cultural icon of Fuji to the vast shield of Mauna Loa, volcanic mountains show us the creative power of heat and pressure rising from deep within the earth. They are reminders that our world is not solid and still, but alive with energy. To see them is to witness the surface expression of forces that never sleep, forces that can in a moment remake the land, but which over time build some of the most awe-inspiring landscapes our planet has to offer. Not all mountains are built by plates colliding head-on, or by molten rock pushing upward. Some arise through the earth being stretched, pulled, and fractured, leaving great blocks of crust lifted, tilted, or dropped. These are the fault block mountains, and their story is one of tension rather than compression, of tearing apart rather than squeezing together. They give us landscapes that look sharp and angular, with long ridges, flat-topped ranges, and deep valleys lying side by side. Imagine the crust of the earth as a vast slab of stone. When pressure pulls it apart instead of pushing it together, cracks form, what geologists call faults. Along these faults, massive sections of rock move up or down relative to one another. The result is dramatic. Some blocks are pushed skyward, creating mountain ranges. Others sink, forming broad valleys or basins. Over millions of years, erosion sharpens their edges, but the fundamental pattern remains, alternating highs and lows, born from the simple act of the planet stretching. One of the clearest examples of this process can be found in the Sierra Nevada of North America. Rising steeply from the eastern edge of California, these mountains are a textbook case of fault block formation. Here, the range is essentially a huge tilted slab of crust. Along its eastern edge, the Sierra rises abruptly, a sheer wall where the land has dropped away on one side of a fault while the other side lifted. The western slope, by contrast, is much gentler, sloping down into the valleys of California. The contrast between the steep escarpment and the rolling foothills is striking, and it speaks to the forces that hoisted the block and left it leaning. The Sierra Nevada is not merely a geological curiosity. Its granite peaks, carved by glaciers and rivers, form some of the most spectacular scenery on the continent. Yosemite Valley, with its soaring cliffs, is carved into this tilted block. Mount Whitney, the highest summit in the contiguous United States, crowns the range, a reminder that even when mountains are lifted by stretching rather than crushing, they can still reach impressive heights. The Sierra shows how faulting can create not just stark landforms, but also some of the most beloved landscapes in the world. If the Sierra Nevada is a tilted slab, the East African Rift is a whole continent being pulled apart. Stretching thousands of kilometers from Ethiopia down through Mozambique, the rift is a gigantic tear in the Earth's crust. Here, Africa is slowly dividing into separate plates, a process that will one day open up a new ocean. As the crust stretches, it fractures along countless faults. Large blocks sink to form rift valleys, while neighbouring blocks remain higher, creating long ranges of fault block mountains. Driving through parts of the rift, you see the land rise in dramatic escarpments before dropping into wide, flat valleys dotted with lakes. These lakes, like Tanganyika and Malawi, fill the sunken basins between fault blocks, some of them among the deepest in the world. To the east and west, mountain ranges stand as the uplifted shoulders of the rift, overlooking the valleys below. The scale of this landscape is immense. Whole nations fit within the boundaries of this tectonic wound. Yet it is also a place of vitality, home to fertile soils, unique ecosystems, and some of humanity's earliest ancestors. Fossils found in the rift tell the story of our own origins, preserved in the shifting ground of a continent in motion. What makes fault block mountains fascinating is the balance between uplift and collapse. Unlike fold mountains where rock is bent and stacked, fault block landscapes show the geometry of broken crust. Straight lines dominate, ridges, cliffs, and escarpments marching across the land. The process may seem destructive, the Earth cracking open, but in reality it is constructive, creating new features and new habitats. In the East African Rift, volcanoes also dot the landscape, fed by magma rising through the thinning crust. Kilimanjaro, though not itself a fault block mountain, owes its presence to the same rifting process. Mountains, valleys, lakes and volcanoes together make the rift one of the most varied geological theatres on the planet. To picture how this works, imagine stretching a piece of dough. As it thins, cracks open, and some parts slump while others remain higher. On the grand scale of continents, the dough is brittle rock, and the cracks are faults that run for hundreds of kilometres. Over time, gravity pulls some blocks downward, while others are thrust upward, exposing rocks that may have been buried for eons. It is a process at once simple and immense, the quiet pull of the planet's plates rearranging the land into steppes, ridges, and valleys. Beyond the Sierra Nevada and the East African Rift, fault block mountains appear in many corners of the world. The Basin and Range province of the western United States is a classic example. From Nevada through Utah and into Arizona and New Mexico, the land is stretched into a repeating pattern of long, mountain ranges and wide valleys. Each range is a block tilted upward, each valley a block that has dropped. The result is a landscape that looks like waves frozen in stone, a rhythmic alternation of highs and lows across thousands of kilometres. These mountains remind us that tectonic forces are not always about collision. Sometimes the Earth's crust is pulled so thin that it breaks, and in that breaking new forms are created. The process is ongoing. Seismic activity in rift zones and fault block regions continues to shift the land. Earthquakes mark the sudden release of tension along faults, jolts that are the audible reminder of blocks moving past one another. These movements, though sometimes hazardous to people living nearby, are part of the natural process of reshaping the planet's surface. Fault block mountains also reveal how varied Earth's mountain-building processes can be. Some mountains rise through fire, others through crushing, and still others through tearing and stretching. Each mechanism leaves its own fingerprint on the landscape. The sharp escarpments of the Sierra Nevada, the sunken valleys of East Africa, the repeating ranges of the American West, all are written in the language of faults and blocks, a vocabulary of fractures and tilts. What is striking is how these broken landscapes so often become cradles of life and culture. In the East African Rift, fertile soils nourish farming communities. In the Basin and Range, mineral-rich rocks have drawn miners for centuries. In the Sierra Nevada, snowmelt from the high peaks feeds rivers that supply water to millions. Mountains born of fractures end up binding human history together, even as they split the land apart. Over geological timescales, fault block mountains are worn down like all others. Wind, rain, rivers and glaciers carve into their sharp profiles, softening the angular edges. Valleys fill with sediments washed from the heights, and new layers cover old scars, yet the underlying structure remains. Even in eroded ranges, the straight lines of ancient faults can be traced, showing where the crust once broke and heaved. These scars are permanent reminders of the planet's restlessness. The story of faults and blocks may seem less dramatic than a volcanic eruption or a continental collision, but in its own way it is just as powerful. Here, the Earth shows what happens when tension triumphs over compression, when the planet is pulled apart rather than squeezed. The result is a world of tilted slabs, sunken basins and towering escarpments, landscapes that testify to the resilience and flexibility of the crust. They are the architecture of stretching, carved not by human hands but by the slow, inexorable pull of the Earth itself. When we think of mountains, it is often the jagged, snow-capped giants that come to mind. The Himalayas, the Andes, the Alps. But some of the most remarkable mountains on Earth are not the tallest, nor the youngest. They are the old ones, softened by time, humbled by erosion, and shaped into gentler forms. These ancient ranges, like the Appalachians of North America and the Scottish Highlands, tell stories that stretch back hundreds of millions of years, far older than many of the lofty peaks we tend to celebrate today. The Appalachian Mountains, running for over 2,000 kilometers along the eastern United States, are some of the oldest mountains in the world. They were once as mighty as the Himalayas, perhaps even taller, their jagged summits rising high above the landscape. But that was long ago, before wind and water, ice and rain, and sheer time itself wore them down. Today they are low, rolling forested ridges and valleys, yet their age makes them extraordinary. Every rounded hill and quiet hollow carries the memory of a mountain chain that towered when dinosaurs had not yet walked the earth, when life in the seas was still experimenting with forms that would later come onto land. To understand just how old the Appalachians are, we need to look back almost 500 million years. Around that time, ancient continents collided during a series of tectonic events known as orogenies. The most dramatic of these was the collision between ancestral North America and Africa during the assembly of the supercontinent Pangaea about 300 million years ago. The force of this impact crumpled and folded the crust, creating a mountain range that likely rivaled or even surpassed today's Himalayas in scale. Imagine colossal peaks rising across what is now the eastern seaboard, with glaciers and alpine valleys cutting between them. The Appalachians were once a geological stage for grandeur on a Himalayan scale. But mountains are not eternal. Even the tallest eventually bow to the slow persistence of erosion. Wind strips away loose material. Rivers cut valleys into their flanks. Glaciers carve deep troughs, and frost splits rock into fragments. Over millions upon millions of years, sharp peaks are rounded, towering summits sink, and the high drama of jagged ridges softens into gentle hills. The Appalachians are the embodiment of this transformation. Their ridges are rounded rather than spiked, their valleys broad and wooded, their rocks exposed not by fresh uplift but by the wearing away of ancient summits. They are not mountains that shout their presence. They are mountains that whisper of a deep and unbroken history. A similar story is written across the Scottish Highlands. Today they appear as windswept plateaus, rugged ridges, and lonely glens, but these landscapes too are fragments of mountains that were once colossal. The Highlands are built largely of some of the oldest rocks in Europe, many dating back to the Precambrian era more than 2 billion years ago. Their mountain-building heyday came during the Caledonian orogeny, a mighty tectonic collision that occurred roughly 400 million years ago when Scotland, then part of a smaller continent, crashed into what would become North America and Greenland. The result was a vast chain of mountains that stretched across the region, possibly rivaling the size of the modern Himalayas. Today, however, those Caledonian peaks are gone, their remains worn into subdued hills and valleys. The highlands we see are what remains after unimaginable spans of erosion. The tall, jagged summits are lost, but in their place lies a landscape of rugged beauty, with deep glens carved by glaciers during the ice ages and high moors swept by winds and rain. The land may be lower, but it carries an undeniable sense of age. To walk among the highlands is to tread across some of the oldest pages of Earth's story. What makes these ancient mountains so captivating is not only their age, but also the way they reveal the cycle of growth and decay in the natural world. Just as living things are born, grow, and eventually fade, so too do mountains. They rise with dramatic force when continents collide, and then they're gradually humbled by the patient hand of erosion. In a way, the Appalachians and the Highlands are portraits of mountains in their later years, still dignified, still beautiful, but bearing the softened outlines of age. These ranges also remind us that erosion is not destruction alone. As mountains are broken down, their material becomes the building blocks for new landscapes. The sediments washed from the ancient Appalachians over hundreds of millions of years helped form the fertile soils of the eastern United States and the coastal plains along the Atlantic. In Scotland, eroded material from the highlands was carried into basins that later became sites of important rock formations, including sandstones and limestones that shape the modern terrain. Mountains may shrink, but in shrinking they contribute to the richness and variety of the world around them. There is also a cultural depth to old mountains. Because they are lower and more hospitable than their towering cousins, they have often been settled, farmed and travelled for thousands of years. The Appalachian valleys and hollows became home to countless communities, their forests offering shelter, their soils providing farmland, their rivers powering early industries. The highlands, though harsher and wilder, are steeped in folklore, poetry and legend. Their glens and bens are etched into the cultural identity of Scotland, symbols of endurance and resilience. Ancient mountains, worn though they may be, become not just geological features but living backdrops to human history. It is tempting to see the Appalachians and the Highlands as faded versions of something grander, but that misses the essence of their beauty. They are not failed mountains, they are completed ones. Their long erosion has revealed layers of rock that tell stories hidden in younger ranges. In the Appalachians, for instance, ancient metamorphic rocks brought to the surface record pressures and temperatures from deep within the earth. In the Highlands, the Louisian gneiss, among the oldest rocks in Europe, lies exposed, giving us a window into Earth's earliest crust. The age and endurance of these mountains allow us to see deeper into time than almost anywhere else. When standing in the Appalachians or Highlands, the grandeur lies not in sheer height, but in perspective. These landscapes stretch the imagination, not with their elevation, but with their history. They teach patience, showing what happens when relentless processes act over millions upon millions of years. They are humbler than the Himalayas, but they speak of endurance and transformation, of the way all things change given enough time, and there is still a quiet majesty to them. Mist drifting through the Appalachian ridges at dawn, or storm clouds rolling over the Scottish Highlands, carries a sense of awe. These older mountains may not tower, but they inspire nonetheless. Their rounded forms and weathered peaks are the work of time's chisel, and their beauty is in that very weathering. They remind us that mountains do not need to be the tallest to be the most profound. They only need to endure, to hold their ground as the world changes around them. In the end, the Appalachians and the Highlands embody the truth that mountains, like all things, are fleeting on the grand stage of Earth's history. Once titanic, now tempered, they are still guardians of ancient stories. They show us that the power of the Earth is not only in what it builds up, but also in what it wears away. These are landscapes where time itself is visible, where every ridge and valley is an echo of a past more immense than we can truly picture. And in their endurance, these old mountains remind us of something humbling. Even the mightiest peaks must one day bow to time. Mountains may rise with a roar of tectonic upheaval, but their slow undoing is written in quieter forces: ice, water, and the endless patience of weather. These are the sculptors of peaks, the artisans of valleys and gorges, working with tools that seem delicate at first glance: melting snow, flowing rivers, falling rain. Yet given enough time, they can carve stone into shapes as dramatic as any uplift ever achieved. The grandeur of mountain landscapes owes as much to their unbuilding as to their birth. Glaciers, for instance, are among nature's most relentless chisels. At first, they appear as little more than compacted snowfields high on summits, quietly accumulating over seasons. But when snow piles year after year and compresses into ice, the mass grows heavy enough to creep downhill under its own weight. It is movement so slow you could watch for a lifetime and never see it shift, yet the results are undeniable. A glacier slides across rock, grinding and gouging as it goes, plucking boulders from cliffs and dragging them like sandpaper across the earth. Over thousands of years, this steady scouring transforms mountain valleys. Where rivers usually cut narrow, V-shaped gashes, glaciers carve wide, sweeping troughs. The famous U-shaped valleys of alpine regions. Think of the Swiss Alps, where graceful glacial valleys stretch between peaks, or Norway's fjords, where ancient ice carved deep corridors that the sea later flooded. In these places, ice was both destroyer and artist, lowering mountains while creating landscapes of breathtaking drama. Even after glaciers retreat, their fingerprints remain everywhere. Cirques, which are bowl-shaped hollows at the heads of valleys, moraines, ridges of rock debris bulldozed into place, and hanging valleys, where smaller glaciers once fed into larger ones, leaving cliffs where waterfalls now plunge. To wander in a glaciated mountain range is to walk through a gallery of forms created by frozen rivers of ice. Water too leaves its signature, though it works in different ways. Flowing rivers are among the most persistent forces shaping mountains. From the smallest trickling brook to a raging torrent, water cuts into rock grain by grain, pebble by pebble. Over time, these streams gnaw at ridges, carving valleys deeper and deeper. When rivers are particularly powerful, or when the land rises beneath them, they slice through bedrock to form deep canyons and gorges. The Colorado River offers one of the world's most striking examples. Over millions of years, it carved the Grand Canyon, an immense gorge revealing nearly 2 billion years of geological history in its walls. Although not a mountain itself, the Grand Canyon demonstrates the sheer persistence of flowing water in reshaping landscapes. In mountain ranges, similar processes are at work on smaller scales. Rivers in the Himalayas, for example, rush down steep slopes, slicing gorges that cut through some of the highest terrain on Earth. These gashes not only sculpt the land, but also channel life, carrying water and nutrients to valleys below, enabling fertile soils and supporting human settlements. What makes water such a formidable sculptor is its adaptability. It flows into every crack, every hollow, and when it freezes, it expands with surprising force. A single droplet of rain that seeps into a crevice in a rock might seem trivial, but when temperatures drop and that droplet freezes, it becomes a wedge. The expansion of ice exerts enough pressure to pry apart even the hardest granite. Over repeated cycles of freezing and thawing, rocks fracture, splinter, and eventually crumble into debris. This process, known as frost weathering, is one of the quietest yet most effective destroyers of mountains. Rain, though gentle in the moment, is equally persistent. Each drop helps to dissolve minerals, carry away sediments, and weaken slopes. Torrential storms can trigger landslides, stripping away whole hillsides in a single event. Over longer spans, rainfall gradually lowers peaks and fills valleys, transporting the mountain's very substance to faraway places. Sediments washed off ridges may journey hundreds of kilometers downstream, eventually settling as deltas at a river's mouth, building new landforms even as old ones are worn away. Then there is chemical weathering, the invisible twin of physical erosion. Water can react with minerals in rocks, transforming them into weaker substances. Limestone, for instance, dissolves slowly in slightly acidic rainwater, creating caves, sinkholes, and unusual rock formations. In mountain ranges where limestone is present, such as the Dolomites of Italy, this kind of weathering produces dramatic cliffs and pinnacles. The mountains are not simply being demolished. They are being reshaped into new forms. Glaciers, rivers, frost, rain, and chemical reactions all share a single trait. They're tireless. They never stop working, even when no one is watching. This constancy is what makes them so powerful. Over a human lifetime, their changes may be subtle, perhaps just a widening of a valley or a slight rounding of a peak. But across millions of years, their handiwork is unmistakable. Entire ranges are lowered, peaks become hills, and jagged ridges smooth into rolling landscapes. And yet there is something paradoxical in this slow destruction. As mountains are worn down, their beauty is often enhanced. A glacier's valley is dramatic, a river's canyon breathtaking, a frost-shattered peak striking in its jaggedness. Destruction and artistry go hand in hand. What erosion removes in height, it often adds in character. It is through this process that mountains achieve some of their most iconic shapes. The Matterhorn, for instance, owes its sharp pyramid form to the combined chiseling of glaciers from multiple sides. Yosemite's half-dome is the product of both glacial carving and exfoliation of rock layers. The sculptors do not simply level mountains, they refine them. These processes also connect mountains to the broader Earth system. The sediments carried by rivers nourish plains and deltas far downstream, becoming the fertile soils that sustain agriculture and human life. Glacial meltwaters feed rivers that support ecosystems and communities long after the ice itself has vanished. Even as mountains crumble, their material continues to shape new landscapes, a constant recycling of the Earth's crust. There is also a rhythm to this sculpting tied to the cycles of climate. Ice ages see glaciers advancing, carving valleys anew, while warmer interludes let rivers dominate the sculpting. In wetter periods, rainfall accelerates erosion, while in arid times wind takes a larger role, carrying away loose sands and shaping ridges. Mountains wear their climate histories on their slopes, each groove, gorge and hollow a clue to the conditions of the past. To sit by a mountain stream or gaze at a glacial valley is to witness this quiet artistry and progress. Nothing dramatic may be happening at that very moment, but the work is ongoing, as it has been for eons. The grandeur of a mountain is not only in its creation, but in its slow surrender to forces that are both gentle and inexorable. These sculptors of ice and water remind us that the earth is never still, that even the most enduring peaks are in motion, flowing downhill one grain of sand, one droplet of rain, one frozen wedge at a time. In the end, mountains are never just monuments of uplift, they are canvases of erosion. Ice gouges, rivers carve, rain dissolves, frost cracks, and slowly the peaks give way. What results is not ruin, but transformation, a shifting balance between building and wearing away. The sculptors of ice and water are not destroyers alone, but artists working with infinite patience, chiseling grandeur into stone. And as long as mountains rise, these forces will be there to shape them, reminding us that nothing, not even the tallest peak, is beyond the reach of time. Mountains may seem like the most immovable things on Earth, yet they live under constant assault from the air above them. The atmosphere does not simply drift overhead. It reaches down with wind, with rain, with frost, and even with the daily shifts in temperature. These forces do not hammer peaks into dust in an instant, but their persistence is astonishing. What tectonics builds up, the atmosphere slowly chisels down, creating a cycle of rise and fall that never truly ends. Wind is perhaps the most invisible but not the least effective of these shapers. High on exposed ridgelines where vegetation is sparse and the air rushes unimpeded, it can sandblast rock surfaces with fine particles. Grain by grain, it scours cliff faces and sharpens ridges. In deserts, where mountains rise from arid plains, wind is often the primary sculptor, carrying sand that etches stone into intricate patterns. Think of the hoodoos and natural arches in dry ranges. They owe much of their form to wind at work. Even in wetter climates, persistent winds can strip soil from slopes, expose bedrock, and polish rock faces into gleaming surfaces that glisten when the light is right. Rain, meanwhile, plays a dual role. It nourishes life on mountain slopes, but it also accelerates their decay. A single storm can unleash torrents that rush down gullies, carrying rocks, mud, and debris with them. Over years, these temporary cascades carve channels, deepening them into ravines. On limestone slopes, rain's chemistry comes into play. Slightly acidic water dissolves minerals, enlarging cracks and sometimes creating networks of underground caves. Rainfall also sets the stage for landslides. When soil becomes waterlogged, slopes can give way, sending entire sections of a mountain tumbling downhill in sudden dramatic movements. Though violent in the moment, such events are simply part of the long, slow dismantling of mountains. Frost, however, is the true master of patience. At first glance, a crisp frost on a mountaintop seems harmless, even delicate. Yet when water seeps into tiny cracks in a rock face and freezes, it expands with surprising strength. Repeated freeze-thaw cycles wedge rocks apart, fragmenting cliffs into piles of rubble known as scree or talus. Over centuries, these slopes of broken stone accumulate at the bases of peaks, silent evidence of the cold, steady power. In places where winters are long and temperatures swing above and below freezing, frost shattering is relentless, chewing into crags and leaving spires jagged and raw. Temperature alone, even without frost, leaves its mark. On some mountains, rocks expand in the heat of the day and contract as night falls. Over time, this thermal stress weakens the stone, causing layers to peel away in slabs, a process known as exfoliation. Yosemite's famous half-dome illustrates this perfectly, with its smooth, curving face the result of immense sheets of granite flaking off over time. It is a reminder that even the simple rise and fall of daily temperatures can, given enough repetition, reshape the hardest surfaces. What makes the atmosphere's touch so interesting is that it works in concert with other forces. Rain may fracture a cliff by dissolving its minerals, then frost pries it further apart, and finally wind whisks away the loosened grains. Each plays its part in a relay of wear and tear, ensuring that no mountain stands unchanged. The drama of mountain ranges, their sharp spires, rugged cliffs, and sweeping valleys, often owes as much to this atmospheric partnership as to the tectonic upheavals that raised them in the first place. In the Scottish Highlands, for example, ancient peaks long ago worn down by erosion are continually reshaped by wind and rain sweeping in from the Atlantic. Their rounded forms are testaments to how long the atmosphere has been at work, polishing jagged heights into gentler silhouettes. By contrast, the peaks of Patagonia, where storm systems slam into the Andes with ferocity, are carved into fierce pinnacles, torn by glaciers but also battered by wind and rain that rarely let up. Mountains in arid climates tell another story. In the American Southwest, for instance, water is scarce, yet when it does arrive, it comes in sudden bursts. Flash floods race through dry canyons, gouging deeper and leaving behind sculpted rock walls streaked with colour. Between storms, the wind carries fine desert dust that smooths surfaces and cuts new alcoves. In such landscapes, the atmosphere is no less active, just more erratic, alternating between long stillness and violent bursts of action. This ongoing atmospheric work feeds into the greater cycle of building and wearing away. Mountains are lifted by tectonic forces at rates of millimeters per year, but at the same time wind, rain and frost are lowering them. In some ranges, the pace of erosion nearly matches the pace of uplift, creating a kind of dynamic equilibrium. The Himalayas, though the highest range on Earth, are also among the fastest eroding thanks to the monsoon rains and the constant grinding of glaciers. Peaks rise, but the atmosphere ensures they do not rise unchecked. This cycle is not one-directional. Material carried away from mountains by wind and rain does not vanish. It is deposited elsewhere, building fertile plains and deltas. Soil eroded from Himalayan slopes helps create the vast, lush Gangetic plain of northern India. Dust blown off desert mountains may fertilize distant rainforests, carrying nutrients across continents. In this sense, the atmosphere's sculpting hand not only dismantles mountains but redistributes their essence, recycling their substance into new landscapes. There is also a poetic side to all of this. To climb a mountain and see its jagged crest is to witness its battle with the atmosphere. Every sharp edge, every cracked boulder, every patch of loose gravel underfoot is a story of rain that once fell, of frost that once froze, of wind that once howled across the ridge. What looks solid and eternal is, in truth, fragile in the face of invisible persistence. The air that brushes your skin is the same air, slowly wearing away the peak you stand on. Over immense spans of time, these forces will bring down even the tallest summits. The mighty Himalayas will one day be as rounded as the Appalachians. The jagged Andes will soften into subdued ridges. The atmosphere is endlessly patient, and mountains, no matter how defiant, cannot outlast it. Yet in their wearing away, they remain awe-inspiring, constantly offering new forms and fresh vistas. The story of mountains, then, is not only one of dramatic birth, but also of gradual surrender. The atmosphere shapes peaks with tools that are soft and unseen, but no less effective than the violence of tectonic collision. Wind strips, rain dissolves, frost fractures, heat expands and contracts. Together they write the second half of the mountain story, ensuring that no summit remains unchanged. It is a cycle as old as the earth itself, building, wearing down, building again, a rhythm played out on the grandest of stages. And in that rhythm lies the quiet lesson of mountains, that permanence is an illusion, and even the tallest, most immovable giants are simply temporary shapes in stone, drawn and redrawn by the restless hands of the atmosphere. Beneath the rolling waves of the oceans lies a world as rugged and dramatic as any mountain range seen on land. In fact, hidden far below the surface is the single longest chain of mountains on Earth, a range that winds its way for more than 40,000 miles, encircling the globe like a seam. It is called the Mid-Ocean Ridge System, and though it lies concealed in darkness, it dwarfs the Himalayas, the Rockies, and the Andes combined. These are mountains we rarely see, but their story is essential to understanding how our planet works. At the heart of the mid-ocean ridge is a process both fiery and slow. Along the seafloor, tectonic plates are pulling apart. As they separate, molten rock from the mantle rises to fill the gap, hardening into fresh crust. Over time, this upwelling of magma piles up, creating underwater ridges and volcanic peaks. Imagine, if you will, a conveyor belt of rock that endlessly produces new ocean floor, while mountains form along its edges. Though these mountains are concealed beneath thousands of feet of water, their creation is relentless, and their scale is almost beyond comprehension. The Mid-Atlantic Ridge is perhaps the most famous part of this global system. It runs right down the centre of the Atlantic Ocean, like a scar across its floor, pushing Europe and Africa slowly farther from the Americas. In some places, it even rises above the surface to form islands such as Iceland, where volcanic eruptions and hot springs remind people daily that the ridge is alive. Iceland is one of the rare spots where we can actually stand atop this immense submarine mountain chain, straddling two continents that are inching apart. Elsewhere, the ridge system remains hidden, but no less extraordinary. The East Pacific Rise, stretching across the Pacific Ocean, is a zone of rapid spreading where new crust forms at remarkable speed compared to other ridges. The mountains here are younger, steeper, and dotted with countless volcanic vents. Though inaccessible to most, robotic submarines have revealed towering ridges, deep valleys, and fields of volcanic chimneys spewing superheated water rich with minerals. These hydrothermal vents, often called black smokers, look like factories built by the Earth itself, releasing plumes that sustain bizarre ecosystems of creatures found nowhere else. One of the fascinating aspects of submarine mountains is that they are still growing. Unlike many mountain ranges on land, which may have passed their prime of uplift, mid-ocean ridges are constantly renewed. Lava erupts, cools, fractures, and is replaced again. If one could fast-forward time, the ocean floor would appear to breathe, opening at the ridge and carrying its newborn crust outward, while the mountain's spine remains as the source. It is a reminder that Earth is not static but alive with movement, even in places we cannot see. Underwater volcanoes, or seamounts, add further complexity to this hidden world. These volcanic peaks can rise thousands of feet above the ocean floor, sometimes breaking through the waves to form islands. The Hawaiian Islands, for example, are part of a long volcanic chain created by a hotspot beneath the Pacific Plate. As the plate slowly drifts over the hotspot, volcanoes rise in succession, one after another, forming a trail of islands and seamounts. Though only the islands at the eastern end are still volcanically active, the submerged remnants stretch for thousands of miles across the ocean, silent witnesses to millions of years of movement. Seamounts are not rare. In fact, there may be over 100,000 of them scattered across the sea floor. Most never break the surface, but they influence ocean currents, provide habitats for marine life, and sometimes grow to astonishing heights. Some rival the tallest peaks on land if measured from their base on the ocean floor. Mauna Kea in Hawaii, when measured this way, is the tallest mountain in the world, taller even than Mount Everest, though most of it lies hidden beneath the Pacific waves. The discovery of these submarine mountains transformed our understanding of the planet. Before the mid-20th century, many assumed the ocean floor was relatively flat and featureless. Then came sonar mapping during the era of naval exploration and warfare, which revealed deep trenches, towering ridges, and mountain chains that made the seafloor as dramatic as any landscape above water. The revelation of the mid-ocean ridges provided some of the strongest evidence for the theory of plate tectonics, showing that the crust was not fixed, but continuously created and destroyed. The seafloor itself became the proof that continents drift. Life has found extraordinary ways to thrive in these hidden mountains. Around hydrothermal vents, where temperatures can exceed 700 degrees Fahrenheit, organisms exist without sunlight, relying instead on the chemistry of the vent water. Giant tube worms, strange crabs, and glowing bacteria form ecosystems that challenge our very definitions of what is possible for life. These creatures live in an alien world of complete darkness, immense pressure, and chemical energy. A reminder that mountains beneath the sea are not barren, but full of vitality. The sheer scale of the mid-ocean ridges is staggering. If all the water were drained away, Earth would reveal a planet wrapped in jagged lines of volcanic mountains, valleys, and seamounts. The ocean basins would look like an alien landscape, carved with peaks higher than the Alps and trenches deeper than the Grand Canyon. It is humbling to realize that the longest mountain range in existence is one that almost no human eyes will ever directly see. Yet even hidden, these submarine mountains shape the world above. The spreading of the seafloor affects sea levels, the chemistry of the oceans, and even the composition of the atmosphere. Volcanic gases released underwater contribute to the global balance of elements. The ridges also influence earthquakes and tsunamis, sending ripples of their activity across continents. In many ways, these mountains, though unseen, hold the reins of global change. There is a quiet poetry to knowing that beneath the waves lies this endless spine of fire and stone, slowly building new earth while the oceans conceal its grandeur. Mountains on land inspire awe precisely because they loom before us, dominating skylines and testing climbers. Mountains under the sea inspire awe for the opposite reason. They are absent from view, colossal yet hidden, reshaping the world silently from the deep. The next time the ocean horizon seems serene, it is worth remembering that far below that calm surface lies a world of restless geology. There, the planet's crust is stretched, torn, and mended in an endless cycle, raising mountains that will never be climbed, peaks that will never break the clouds, yet whose story is every bit as grand as the summits that scrape the skies. These are the mountains of the deep, the Earth's longest and most secret chain, a wonder hidden in plain sight beneath the blue. Mountains may look like stone fortresses from afar, but step closer and they reveal themselves as living worlds. These are not simply heaps of rock thrust skyward by the Earth's restless crust. They are vertical landscapes, each elevation hosting its own climate, its own community of plants and animals, and its own fragile balance. As you climb higher, life shifts in quiet, remarkable steps, like turning the pages of a natural encyclopedia. At the base of most great mountain ranges lies a lush foothill zone, where valleys cradle farms, forests, and rivers. Here the air is rich with oxygen, the climate is relatively mild, and species thrive much as they do in the surrounding lowlands. But as soon as you begin to ascend, subtle changes begin. The temperature cools, the air thins, and vegetation starts to rearrange itself, adapting to shorter growing seasons and harsher conditions. One of the most enchanting bands is the montane forest zone. Depending on where you are in the world, this may be filled with pine, spruce, fir, or tropical cloud forests dripping with mosses and orchids. These woodlands are havens of biodiversity, offering shelter to bears, deer, and songbirds. In the Andes, the cloud forests are so rich with life that they are often described as the lungs of the earth, producing moisture that feeds rivers for thousands of miles. Within the Himalayas, vast forests of rhododendron bloom in dazzling pink and red each spring, transforming the slopes into seas of colour. As the climb continues, the trees thin out, branches twist against the wind, becoming stunted and sparse. Eventually the tree line is reached, that invisible boundary above which no forest can grow. The reasons are simple yet profound. Cold temperatures, short growing seasons, and the low density of oxygen make it impossible for trees to survive. What lies beyond the tree line is a realm of meadows and grasslands known as the alpine zone. These alpine meadows, bursting with flowers in summer, are some of the most beautiful places on Earth. Here, hardy plants cling close to the ground, forming cushions to resist the cold and wind. Tiny alpine gentians, edelweiss and saxifrages paint the slopes in delicate purples, whites and yellows. It is a landscape of miniatures, low shrubs, creeping herbs and lichens, all engineered by evolution to withstand extremes. For a few fleeting months, the meadows come alive with buzzing insects and grazing animals such as ibex, marmots, or Himalayan tar. Then, as swiftly as they bloomed, the flowers vanish under snow once more. Animals in these zones live at the edge of possibility. Mountain goats leap with astonishing agility across sheer cliffs, their hooves adapted for gripping narrow ledges. Snow leopards, masters of stealth, pad silently across rocky slopes, their thick fur cloaking them against the cold, and their long tails serving as both balance and blanket. Even smaller creatures have their secrets. Pikas, rabbit-like mammals of Asia and North America, gather piles of grass during summer to dry in the sun like miniature haystacks, which they then use as winter food stores. Higher still, glaciers dominate the landscape. These rivers of ice, flowing at a pace measured in inches per year, are the architects of mountain valleys, carving cirques and sharpening peaks into the jagged shapes we admire today. Life here is sparse, but not absent. Algae can bloom on the very surface of ice, staining it pink or green. Some insects, like the iceworm, have adapted to live within the frozen surface itself, wriggling through tiny films of meltwater between crystals of ice. It is a reminder that even in the most unforgiving places, life finds a way. Altitude transforms not only plants and animals, but also the very air we breathe. With every 1,000 meters of ascent, the atmosphere thins, reducing the oxygen available. For people and animals unaccustomed to high altitudes, this can lead to dizziness, fatigue, and altitude sickness. Yet communities across the globe have adapted to life high in the mountains. In the Andes, Quechua and Aymara peoples thrive at altitudes where the air contains almost half the oxygen found at sea level. Generations of adaptation have given them larger lungs and higher concentrations of hemoglobin, allowing their bodies to absorb and carry oxygen more efficiently. In Tibet, communities living at over 14,000 feet have developed different adaptations, including faster breathing and blood circulation, proving that evolution works in multiple ways to solve the same challenge. Mountains also host unique microclimates. A single slope can hold a patchwork of ecosystems, shaped by sunlight, shade, wind, and moisture. South-facing slopes may be warm and dry, nurturing grasses and shrubs, while north-facing slopes remain cool and damp, sheltering mosses and fungi. Valleys can trap mist and humidity, creating miniature rainforests just a few steps away from arid ridges. This variety makes mountains some of the most biodiverse environments on Earth, despite their seemingly harsh conditions. Perhaps most striking of all is the way mountains act as water towers of the world. Snow and glaciers store water throughout the winter, slowly releasing it as melt in the spring and summer. Rivers fed by these mountain sources supply drinking water, agriculture, and hydropower for billions of people. The Ganges, Yangtze, and Amazon rivers, among many others, owe their existence to mountain glaciers and snowpacks. Without them, life in the valleys and plains below would be unrecognizable. Yet these living mountains are also fragile. Ecosystems at high altitude are finely tuned and vulnerable to disruption. Climate change, for instance, is altering snowfall patterns and shrinking glaciers at alarming rates. Plants that once bloomed in perfect harmony with the melting of snow now risk missing their window, while animals dependent on seasonal cycles struggle to adapt. The snow leopard, already elusive, faces the loss of habitat as warming temperatures push tree lines higher, narrowing the alpine meadows that once provided prey. Despite these challenges, mountains remain sanctuaries of resilience. They remind us that life is not only about thriving in comfort, but also about enduring in extremes. Alpine plants that bloom under snow, insects that live in ice, and birds that soar where humans gasp for breath, all illustrate the astonishing adaptability of nature. To walk through a mountain ecosystem is to experience the earth in layers, stacked not in miles across a map but in steps upward along a slope. In a single day, one can journey from temperate valleys filled with orchards to icy ridges where little grows at all. Each elevation tells a different story, each band of life a different experiment in survival. Mountains teach that altitude is not simply height, but a sculptor of worlds. They offer more than dramatic summits. They hold entire universes of plants, animals and climates, arranged like shelves in a vertical library. From forest to meadow, from meadow to glacier, they reveal the elegance of life adapting to challenge after challenge. In the stillness of these heights, surrounded by peaks and sky, it becomes clear that mountains are not just landscapes. They are living, breathing realms where nature writes its most patient and intricate stories. From the very beginning of human storytelling, mountains have been more than rocks and ridges. They have been thresholds, sacred spaces, and symbols of the unreachable. For ancient peoples gazing upward, peaks appeared as ladders to the sky, closer to the divine than the flat plains where ordinary life unfolded. It is no wonder that nearly every culture has filled its mountains with gods, myths, and meaning. Consider Mount Olympus in Greece. Rising above the Aegean coast, it was imagined as the home of the Olympian gods, a celestial palace hidden by clouds. To the Greeks, its summit was unreachable, and therefore perfect for the immortals. No mortal dared set foot upon its highest reaches, not because of fear of altitude, but because it was believed to be the dwelling place of thunderbolts and divine judgment. In story and song, Olympus was less a pile of limestone than a throne room in the sky. Travel eastward and the Himalayas dominate the imagination. Mount Kailash, an isolated pyramid-shaped peak in Tibet, has never been climbed, not because it is unclimbable, but because it is held sacred by several religions. In Hinduism, it is the abode of Shiva, lord of transformation and destruction. In Buddhism, it represents Mount Meru, the axis of the universe around which all of creation spins. Pilgrims still walk its base in ritual circumambulation, believing that one circuit can cleanse a lifetime of sins. To attempt the summit, however, would be to trespass on divine ground. The Andes of South America tell another story. For the Inca and their predecessors, towering summits were not just geological features, but living beings. Mountains, or apus, were guardians and deities, protectors of valleys and people. Offerings were made high on their slopes. Food, textiles, and in some cases human sacrifices, meant to appease these mighty spirits. Archaeologists have uncovered shrines and mummified remains atop peaks like Mount Lulaya Laco in Argentina. preserved for centuries in ice, silent testimony to the seriousness with which mountains were woven into spiritual life. Even in the Middle East, where mountains are fewer but equally striking, their symbolic weight is immense. Mount Sinai is the site where Moses is said to have received the Ten Commandments, a place of revelation and covenant. In Islamic tradition, the cave of Hira on Mount Nur is where the Prophet Muhammad received his first revelations from the angel Gabriel. These stories underscore a recurring idea. Mountains are places where the human and the divine touch. In Japan, Mount Fuji is more than a natural wonder. It's a sacred volcano, revered in Shinto belief as the dwelling place of deities and venerated in art and poetry for centuries. Its almost symmetrical cone rising above mist and cherry blossoms has become a national icon, a symbol of endurance and beauty. Pilgrimages to its slopes remain popular, with climbers reaching the summit not only for the view, but as an act of spiritual completion. Closer to northern Europe, mountains inspired tales of giants and spirits. The Norse imagined the bones of slain frost giants becoming the very bedrock of mountains, their skulls forming domes, their blood filling fjords. In Celtic tradition, mountains and hills were believed to house the entrances to the otherworld, realms of fairies and gods. The Scottish Highlands, now admired for their rugged scenery, were once threaded with stories of hidden folk and ancient powers. In China, mountains are inseparably tied to both spirituality and philosophy. The 5 great mountains, Tai, Hua, Song, Heng in the north, and Heng in the south, are sacred in Taoist and Buddhist tradition. They were places of pilgrimage for emperors and hermits alike, representing the balance of yin and yang and the search for harmony between heaven and earth. To this day, temples crown their ridges, and pilgrims climb their stone stairways in quiet devotion. Mountains also shaped cosmologies far from Asia and Europe. In Native American traditions, peaks hold deep meaning. The Navajo regard the San Francisco peaks in Arizona as one of their 4 sacred mountains, marking the boundaries of their homeland. Each mountain carries a colour, a direction, and a spiritual role. Among the Lakota, the Black Hills are sacred as the centre of the world, a place of origin and renewal. In these traditions, mountains are not distant or abstract. They are intimate relatives, alive and watchful. The symbolism of mountains extends beyond religion. They have come to stand for endurance, aspiration and challenge. To scale a mountain is to overcome an obstacle. To reach a summit is to achieve something greater than oneself. This metaphor has crossed into language, art and philosophy. The phrase, mountain to climb, is now common shorthand for difficulty, and poets across centuries have compared the search for wisdom to the long, steep trek up a peak. Art and literature have preserved these ideas in countless forms. The Chinese landscape paintings of misty mountains are not just depictions of scenery, but expressions of philosophy, suggesting humility before nature's immensity. In Romantic Europe, painters and poets found the sublime in mountain landscapes, a mixture of awe and terror in the face of vast, untamable heights. Wordsworth and Shelley wrote of alpine peaks as places where human hearts could expand and imagination could soar. Yet even as symbolism shifted, one constant remained. Mountains inspire reverence. Whether as the dwelling places of gods, the bones of giants, the guardians of valleys, or metaphors for human struggle, they occupy a unique place in the human imagination. They are at once physical and metaphysical, real and otherworldly. Perhaps what makes them so powerful in human culture is their duality. Mountains are enduring yet fragile, welcoming yet forbidding, visible yet often unreachable. They stand as reminders of permanence while also changing constantly through erosion and weather. In this way, they mirror the paradoxes of human existence, longing for eternity, yet bound by time. Across civilizations, from the Greeks gazing at Olympus to the pilgrims walking around Kailash, from the Inca praying to Apis to the Japanese artists sketching Fuji in ink, mountains have served as bridges between earth and sky. Their presence looms in myth, in faith, and in art, shaping how societies view the natural world and their place within it. Even today, when satellites can map every ridge and climbers can scale almost any summit, the old reverence lingers. Sacred peaks remain untouched, protected not by their sheer cliffs, but by cultural taboos and spiritual respect. Legends are still told of gods and spirits dwelling above the clouds, and whenever someone looks up at a towering summit and feels something beyond words, awe, humility, inspiration, they are part of the same long story that has bound people to mountains since the dawn of history. For most of human history, mountains were approached with awe, respect, and often fear. They were not places to climb, but barriers to skirt around, sources of water and weather, or homes of gods and spirits that one would not dare disturb. Yet curiosity is a persistent trait, and over time the peaks that once loomed as forbidding walls began to be seen as challenges waiting to be overcome. The history of mountaineering is as much a story of shifting perspectives as it is of ropes, boots, and ice axes. The earliest explorers of mountains were rarely adventurers seeking glory. Many were surveyors, map-makers, or shepherds. Practicality drove them upward, whether to chart borders, tend livestock, or cross from one valley to another. In the Alps, for example, passes such as the Great St. Bernard had been traversed for centuries as trade routes. Hannibal even led elephants through alpine snow when crossing into Italy during the Punic Wars, proving that determination could take the strangest cargo over formidable heights. These crossings were feats of endurance, but they were not about scaling summits for the sake of standing atop them. The idea of climbing a mountain simply to reach its peak took much longer to catch on. In the 16th century, scholars began to view mountains less as curses upon the land, and more as wonders worth studying. A turning point came in 1492, when Antoine de Ville climbed Mont Aiguille in France using ladders and ropes, largely for curiosity and prestige. This was one of the earliest recorded ascents for no reason other than exploration. Still, for centuries afterward, the peaks of Europe remained mysterious and intimidating, cloaked in superstition and danger. It was during the Enlightenment that attitudes began to shift more dramatically. As science flourished, so too did interest in geology, meteorology, and cartography. Peaks became laboratories in the sky. In 1786, Mont Blanc was climbed by Jacques Balmat and Michel Gabriel Paccard, a milestone often considered the birth of modern alpinism. Standing on the highest summit in Western Europe, they opened the way for a new era of mountaineering, blending science, sport, and sheer determination. Soon after, the Alps became the playground of adventurers, scientists, and romantics alike. By the 19th century, the so-called golden age of alpinism was in full swing. British climbers, fascinated by the Alps, made first ascents of many peaks, including the Matterhorn in 1865, a climb that ended in both triumph and tragedy when 4 climbers fell to their deaths on the descent. The stories of danger only seemed to fuel the mystique. Mountains were no longer obstacles to avoid, but arenas where human endurance, skill, and courage were tested. As the Alps were mapped and conquered, attention turned to loftier goals farther afield. The Himalayas, Karakoram, and Andes presented altitudes far beyond anything in Europe. These ranges became the new frontier of exploration, and expeditions were mounted with almost military precision. Mountaineering evolved into a discipline requiring planning, teamwork, and national pride. In the Age of Empire, to climb a great peak was to plant a flag not only on a summit, but also in the imagination of the world. Among these peaks, Everest loomed supreme, known to Tibetans as Chomolungma, the goddess mother of the world, and to Nepalis as Sagarmatha, the forehead of the sky. It was the highest mountain on Earth. Western interest intensified in the early 20th century, but Everest was no simple conquest. The thin air above 8,000 meters, now called the death zone, presented physiological limits that no one fully understood. Early expeditions in the 1920s saw George Mallory and Andrew Irvine vanish high on the slopes. Whether they reached the summit before perishing remains one of mountaineering's great mysteries. Mallory's famous reply to the question of why climb Everest, because it is there, captured the strange mix of fatalism and fascination that defines high-altitude climbing. It was not until 1953 that Everest was officially climbed to the summit, when Sir Edmund Hillary of New Zealand and Tenzing Norgay, a Sherpa of Nepal, stood on the roof of the world. Their achievement was broadcast around the globe and became a symbol of post-war human triumph. It was also a reminder that mountaineering was not just about individual glory, but about collaboration, endurance, and trust. Without Sherpa expertise, equipment advances, and years of planning, no summit would have been possible. Beyond Everest, other peaks carried their own allure. K2, the second highest mountain in the world, earned a reputation as the Savage Mountain. Taller than almost all others, it is less forgiving than Everest, with steeper slopes, harsher weather, and fewer routes to the top. Climbers often remark that while Everest can be crowded with hopeful summiteers, K2 remains a place of stark solitude, where the margin for error is razor thin. Annapurna, another Himalayan giant, has historically claimed an even higher percentage of lives, a stark reminder that beauty and danger go hand in hand at such altitudes. Technology and equipment slowly transformed the risks. Oxygen tanks, synthetic fabrics, crampons, and lightweight tents expanded the limits of what was possible. A climb that once took weeks could be done in days with the right gear. Yet mountains remained unpredictable, and human ambition often collided with the raw forces of nature. Avalanches, storms, and altitude sickness continued to claim lives, humbling even the strongest. Exploration was not limited to the highest peaks. The mapping of ranges such as the Rockies, the Andes, and the African highlands was itself a monumental achievement. Surveyors carried cumbersome equipment across glaciers and deserts, painstakingly charting contours that would eventually fill atlases. The simple act of placing a peak on a map was often as difficult and dangerous as climbing it. These maps became tools for future adventurers and symbols of expanding human knowledge. As the 20th century wore on, mountaineering diversified. Some climbers pursued the Seven Summits, the tallest peak on each continent, while others specialized in technical ascents on sheer rock faces. Still others focused on speed, pushing themselves to climb faster, lighter, and with fewer aids. Each approach reflected a different philosophy of what it meant to conquer a mountain, whether through endurance, skill, or purity of style. The lure of high places has never been just about reaching the top. For many, it is about perspective. To stand on a peak, even a modest one, is to see the world differently, to look out over valleys and rivers as if glimpsing the structure of the planet itself. The air feels cleaner, the silence more profound, and the horizon wider than imagination. These moments fuel the desire to climb again, despite the risks. Mountains, in their way, resist conquest. They outlast empires and generations, enduring through storms and centuries while climbers come and go. To climb them is not to master them, but to briefly share in their vastness. From the Alps to the Himalayas, from mapping expeditions to daring solo ascents, the human journey into the heights is as much about inner landscapes as it is about outer summits. The peaks stand as both challenge and invitation, reminding us that curiosity can draw people into places where the air is thin, the ground is steep, and the sense of wonder is immeasurable. Mountains are more than just striking features of the landscape. They are some of the most enduring political boundaries on Earth. Rising like walls, they have kept cultures apart, defined territories, and at times provided fortresses in which entire peoples could survive against invasion. Their very existence has influenced the course of history, shaping nations, alliances, and conflicts in ways as dramatic as their snow-capped peaks. For much of human history, mountains served as natural lines of defense. Long before modern borders were drawn with ink and treaties, ridges and ranges provided ready-made divisions. The Himalayas, for instance, are not simply the tallest mountains in the world, but also one of the most effective barriers ever created by nature. Their massive walls of rock and ice separate the Indian subcontinent from the Great Plains of China and Central Asia. For centuries they acted as both shield and obstacle, slowing armies and limiting cultural exchange to a few perilous passes like the Silk Road routes through Kashmir and Tibet. These pathways carried traders, monks, and travellers, but their difficulty meant that the flow of goods and ideas remained selective and rare compared to open plains. In Europe, the Alps played a similar role. They form a formidable barricade across the heart of the continent, a jagged seam that historically divided the Italian peninsula from the northern lands. Armies struggled to cross them, and only the most determined invaders, like Hannibal with his elephants or Napoleon with his troops, managed the feat. Even then, the mountains extracted their toll. Soldiers froze, supplies dwindled, and the sheer terrain dictated the rhythm of campaigns. The Alps became a kind of stern referee of history, deciding which empires could stretch their reach and which would falter. The Pyrenees, running between France and Spain, provide another textbook case. They have long separated Iberia from the rest of Europe, acting as both political and cultural frontier. To the north, French influence spread, while to the south, distinct kingdoms such as Aragon and Castile developed largely in their own orbit. The mountains made conquest difficult, so instead of being swallowed up by larger neighbours, the peoples of the Iberian Peninsula developed unique languages, traditions and political structures. The stubborn resilience of Basque culture, tucked deep within the folds of the Pyrenees, owes much to this rugged natural insulation. Mountains are not only barriers but also bargaining chips in the complex game of geopolitics. The Himalayas again illustrate this, as modern nations such as India, China, Nepal and Bhutan argue over where exactly the frontier should run, along jagged peaks and high-altitude plateaus. Borders drawn on paper sometimes fail to match the reality of glaciers and cliffs, leading to disputes and even armed clashes. The Siachen Glacier, at over 5,000 metres in altitude, remains one of the highest battlegrounds in the world, where India and Pakistan maintain troops in conditions more hostile than many polar stations. Soldiers there face frostbite and avalanches as much as enemy fire, a stark reminder that mountains themselves can be as formidable as any opponent. The Andes of South America stretch for thousands of kilometres, forming a continuous spine that separates coastal lands from the interior. This vast wall helped define nations such as Chile and Argentina, whose borders run along the high ridges. The mountains also shaped political destinies. For instance, during the Wars of Independence in the early 19th century, General José de San Martín led his army across the Andes in a daring manoeuvre that shocked Spanish forces in Chile. The mountains that seemed to lock regions apart could, in the right moment, provide a strategic advantage for those bold enough to attempt the crossing. In Africa, the Atlas Mountains have historically separated the Mediterranean facing north from the Sahara to the south. This divide not only influenced the development of distinct cultures, but also dictated trade patterns. Caravans carrying salt, gold, and slaves moved through passes in the Atlas, linking sub-Saharan Africa with the wider Mediterranean world. The mountains were less a wall than a filter, shaping how goods, ideas and peoples flowed across the continent. Not all mountains serve as neat dividers. Some ranges are so vast that they become contested frontiers rather than clear boundaries. The Caucasus Mountains, wedged between the Black Sea and the Caspian, are a prime example. Home to a bewildering array of ethnic groups and languages, the region has long been a patchwork of rival claims. Empires from Persia to Russia sought to control it, but the sheer complexity of its terrain and peoples made it notoriously difficult to dominate. Even today, the Caucasus remains politically sensitive, a place where mountains both shelter communities and fuel disputes. Mountains can also forge identities that defy national boundaries. The Alps, while dividing Italy from northern Europe, also fostered a shared alpine culture that spanned Switzerland, Austria, France, and beyond. Inhabitants of high valleys speaking different languages nonetheless developed similar traditions of herding, farming and architecture shaped by the demands of mountain life. The peaks imposed certain practical realities: steep pastures, heavy snow, seasonal isolation that overrode political borders and created bonds of common experience. In more recent times, mountains have taken on symbolic value in addition to their strategic importance. The borders they mark are not just lines on a map, but emblems of sovereignty and pride. The summit of Mount Everest, for example, sits on the boundary between Nepal and China's Tibet Autonomous Region, a fact that has diplomatic weight in discussions of tourism and climbing rights. Similarly, Mount Ararat, towering in modern Turkey, is considered by Armenians as a national symbol despite lying outside their current borders. The mountain embodies cultural memory and identity, demonstrating that mountains are not only physical frontiers, but also powerful markers of belonging. It is also worth noting that while mountains divide, they sometimes unite by necessity. Harsh terrain can force cooperation in order to survive. The Himalayas, despite their role as barriers, also created shared traditions among the Sherpa, Tibetan and Ladakhi peoples who learned to live at high altitude. These mountain communities became essential guides and traders, bridging worlds that otherwise might have remained disconnected. Similarly, the people of the Andes built civilizations adapted to altitude, inventing terrace farming and domesticating llamas and alpacas. Their innovations bound together regions otherwise fractured by terrain. Conflicts rooted in mountains are not only military, but also environmental. As nations define their borders along ranges, disputes often arise over water. Glaciers and snowfields in mountain ranges serve as vital reservoirs, feeding rivers that millions depend upon. Control of these sources can be just as contentious as land itself. In regions like the Himalayas, arguments over river systems such as the Indus and the Brahmaputra are intertwined with mountain borders, blending geography, ecology and geopolitics into a single complicated knot. The role of mountains as borders reminds us that geography is never passive. These giant formations do not merely decorate the land, they steer the flow of armies, shape the destiny of states, and influence the imagination of entire civilizations. Nations may negotiate treaties, redraw boundaries, or fight wars, but the mountains stand largely unmoved, indifferent to human ambitions. They are at once arbiters and silent witnesses, sculpting the human story as surely as they sculpt the land itself. From the Pyrenees to the Andes, from the Himalayas to the Caucasus, mountains have written their presence into the history of nations. Sometimes they have granted security, other times they have incited conflict, but always they have demanded respect. To study them as borders is to understand that the jagged horizon is never just scenery. It is politics, culture, and power etched into stone. Mountains are often thought of as lofty fortresses of rock and snow, but they are also reservoirs of life. In many ways, they act as the planet's great water towers, storing and releasing fresh water in a slow, dependable rhythm that sustains billions of people. Without them, the great rivers of the world would be shadows of what they are, and the landscapes they nourish would wither. At their most fundamental, mountains gather water in the form of snow and ice. Their high altitudes and cold climates allow glaciers to form, and these frozen masses become long-term banks of fresh water. When the sun warms the slopes, meltwater trickles down into valleys, feeding rivers that grow into mighty waterways. Consider the Himalayas. Their glaciers and snowfields give rise to some of Asia's most important rivers, including the Ganges, the Indus, and the Brahmaputra. Together, these rivers support hundreds of millions of people, from high-altitude villages to sprawling cities on the plains. The monsoon rains may come and go, but the Himalayas provide a more stable, year-round drip feed of water. The Andes in South America serve a similar role. Snow and glacial ice from these peaks supply water to rivers such as the Amazon and the Paraná. In arid regions like coastal Peru and Chile, mountain runoff makes agriculture possible where rainfall alone is insufficient. Crops that sustain entire populations, corn, potatoes, coffee and vineyards, depend on water released by the mountains. Without the Andes' hidden reservoirs, much of South America's agricultural heartland would dry out. Even smaller ranges play this role on a local scale. The European Alps, though far shorter than the Himalayas or Andes, feed some of Europe's most famous rivers. The Rhine, the Rhone, the Danube and the Po all begin their journeys in these mountains. As they wind their way through multiple countries, they provide drinking water, irrigation and hydropower to millions. It is no exaggeration to say that Europe's economy has been built in part on the rivers born in the Alps. The Rocky Mountains in North America also act as a continental divide for water. Snowpack collected in winter gradually melts throughout spring and summer, feeding rivers that flow both east and west. On one side, the Colorado River winds its way through desert lands, delivering life-giving water to regions that would otherwise be barren. On the other side, the Missouri and Mississippi systems grow into some of the largest rivers in the world, sustaining agriculture and transportation across vast plains. In both directions, the Rockies function as the high-altitude spigot that keeps landscapes hydrated. Mountains not only supply rivers, they also regulate their flow. The glaciers and snowpack act as buffers against extreme drought and flood. In times of scarce rainfall, meltwater keeps rivers running, ensuring that ecosystems and communities do not collapse entirely. In times of heavy rain, mountains absorb and release water more gradually, preventing rivers from swelling too fast. This delicate balance is especially critical in regions where seasonal variability is extreme, such as the Himalayas, where the wet monsoon is followed by long, dry months. Yet these natural water towers are under increasing stress. Climate change has begun to shrink glaciers around the world, threatening the steady trickle of meltwater that so many depend on. In the Andes, glaciers that have endured for centuries are retreating, leaving some communities worried about their future water supplies. The same story is unfolding in the Alps, the Rockies, and even the Himalayas. What once seemed like an infinite reservoir is revealing its limits, and the consequences ripple far beyond mountain valleys. For people living downstream, the importance of mountain water is often invisible. Few city dwellers pause to consider that the river flowing through their town might have started as a trickle of meltwater on a distant peak. Cairo owes its existence to the Nile, whose headwaters trace back to the highlands of Ethiopia and Central Africa. Beijing relies heavily on rivers that descend from the Tibetan Plateau. Lima, perched on the dry Pacific coast of Peru, is sustained by streams fed by the Andes. Entire civilizations rise and fall, depending on whether mountain-fed rivers continue to flow. It is not only human societies that rely on this gift. Rivers carry mountain water across entire ecosystems, nurturing forests, grasslands, wetlands and estuaries. Fish migrate up rivers to spawn, birds follow river corridors on their migrations, and countless species depend on the shifting balance of water levels through the seasons. When mountain glaciers diminish, it is not just farms and cities that feel the loss. Entire webs of life unravel. Another crucial service mountains provide is storing water underground. As snow melts, much of it seeps into porous soils and rock layers, replenishing aquifers. These hidden reserves are tapped by wells, springs and irrigation systems, often far from the mountains themselves. In this way, mountains act as both visible and invisible reservoirs, shaping the hydrology of regions hundreds or even thousands of kilometers away. Historically, communities that live near mountains learn to adapt their way of life to the rhythms of meltwater. Ancient civilizations in the Andes constructed intricate networks of canals and terraces to capture runoff and use it efficiently. In the Himalayas, farmers practiced crop rotations and seasonal migrations to take advantage of varying water availability. Even today, mountain peoples are some of the most skilled at balancing fragile water resources, because they have no choice but to live in harmony with the peaks above them. Modern engineering has amplified the role of mountains as water towers. Dams and reservoirs built along mountain-fed rivers harness their energy for hydropower, while also storing water for agriculture and cities. The Hoover Dam on the Colorado River and the Aswan Dam on the Nile both rely on flows originating in distant highlands. Yet this reliance comes with risks. If the mountain sources fail, the downstream infrastructure becomes useless, a reminder that no human system can function without the foundation provided by nature. The title Water Towers of the World is more than a poetic phrase. It reflects the central truth that mountains hold the key to freshwater security. As populations grow and demand for water increases, the role of these high-altitude reservoirs will become even more critical. Protecting mountain ecosystems, from glaciers and snowfields to forests that regulate runoff, is essential for human survival. Without them, rivers will falter, crops will fail, and cities will thirst. To gaze at a mountain capped with snow is to see a promise written in ice, a promise of rivers, of fertile valleys, of life carried downstream. These colossal towers stand silently, releasing their gifts day by day, season by season, year after year. They are not only monuments of stone, but also fountains that never cease, sustaining worlds far beyond their slopes. To understand mountains as water towers is to realize that their true power is not only in their height, but in their ability to quench the thirst of the earth itself. Mountains, though seemingly frozen in grandeur, are never truly still. Their peaks might look eternal, standing solid against the sky, but deep inside the earth and along their flanks, they are constantly being reshaped. Some are slowly rising higher, others are gradually wearing down, and all of them are engaged in a delicate balance between the upward push of tectonic forces and the downward pull of erosion. What appears to us as timeless stability is, in reality, a restless tug-of-war that plays out over millions of years. At the heart of this dance lies a process called uplift. It occurs when tectonic plates collide, bend, or stretch, forcing rock upwards. The Himalayas, for instance, are the most dramatic modern example. India continues to crash into Asia at a rate of several centimetres per year, and in response the mountains are still being thrust skyward. Mount Everest, already the tallest peak on Earth, is not fixed at its present height. Each year, the whole range creeps upward ever so slightly, as though it is still stretching from the colossal impact that began over 50 million years ago. But uplift is not always about violent collisions. Sometimes it happens more subtly, through processes like isostasy. Imagine Earth's crust as a raft floating on a dense, slow-flowing sea of mantle. When erosion strips material from the top of a mountain range, the crust becomes lighter and it bobs upward to restore balance. This is the same principle you see when ice melts off the top of an iceberg. Less weight above means the base rides higher. Scandinavian mountains, for example, are still rebounding today after massive ice sheets that once weighed them down melted away at the end of the last ice age. The ground there is literally rising back up, centimetre by centimetre, as though the earth itself is sighing in relief after shedding its icy burden. As mountains rise, erosion is busy pulling them back down. Wind, rain, frost, and the relentless flow of rivers act as chisels against the hardest rock. Even glaciers moving at the pace of centuries grind entire valleys into shape. The result is a ceaseless cycle. Tectonic forces push mountains upward, while surface processes wear them away. Over geological time, this balance can lead to landscapes that are surprisingly stable in height, even though the rocks within them are constantly moving. The Southern Alps of New Zealand, for example, rise quickly because of powerful tectonic uplift, but the equally vigorous erosion caused by heavy rainfall keeps them from soaring indefinitely. They are caught in equilibrium, always being renewed, yet always worn down. Seismic activity often provides reminders that mountains are alive beneath the surface. Earthquakes are the sudden releases of energy that accompany the slow build-up of stress along faults. In regions like the Andes or the Himalayas, a single quake can shift entire ridgelines by meters. Though such events are violent and disruptive for human societies, they are part of the natural mechanism that reshapes and uplifts ranges over long timescales. Each tremor is a punctuation mark in the ongoing geological story of mountains in motion. Volcanic mountains too illustrate this dynamic state. The Cascades in North America, the Japanese archipelago, and the Andes are all volcanic chains that are both rising and eroding at the same time. Each eruption adds new layers of ash and lava, building height, while rainfall, glaciation, and landslides steadily tear them down. Mount St. Helens in Washington famously lost a large portion of its summit in the 1980 eruption, only to slowly rebuild in the decades since. The mountain is a perfect example of the dynamic tension between destruction and renewal. Satellite technology has allowed scientists to measure these movements with remarkable precision. By bouncing signals from space off the Earth's surface, geodesists can detect even millimetre-scale changes in elevation. This has revealed fascinating details. Parts of the Himalayas rise several millimetres each year, while Iceland swells as magma accumulates beneath it. The Andes continue to thrust upward as the Pacific Plate dives beneath South America. To us, these changes seem imperceptible, but over millions of years they add up to entire landscapes transformed. Erosion, on the other hand, is not simply destruction. It also gives mountains their character. Without erosion, ranges would be blunt piles of rock, lacking the jagged peaks, sweeping valleys, and dramatic cliffs we associate with them. The pointed spires of the Dolomites in Italy, the sharp ridges of the Rockies, and the U-shaped valleys of Norway all exist because erosion sculpted, uplifted rock into something more intricate. Mountains are not just lifted, they are carved, refined, and polished by the atmosphere and hydrosphere working hand in hand. In some places, the pace of uplift outstrips erosion, giving rise to towering ranges like the Himalayas or the Andes. In others, erosion dominates, whittling ancient giants into low, rounded hills, as seen in the Appalachians or Scottish Highlands. Both are parts of the same continuum. Mountains grow, they wear down, they rise again, and they change shape. Nothing is fixed, not even the hardest granite. This balance of uplift and erosion also influences global climate. As mountains rise, they alter weather patterns, forcing air masses upward and wringing moisture from clouds. At the same time, the freshly exposed rock surfaces provide raw material for chemical weathering, a process that pulls carbon dioxide from the atmosphere. In this way, mountain growth can even help regulate Earth's long-term climate cycles. The rise of the Himalayas, for example, is thought to have contributed to global cooling over the past tens of millions of years by accelerating chemical weathering of silicate rocks. For human beings, the imperceptible motion of mountains sometimes becomes startlingly clear. When glaciers retreat, entire valleys can rebound upward. When rivers carve deep canyons, the uplifted land reveals ancient strata like pages of an open book. Even landslides, dramatic though they are, remind us that gravity and erosion never rest. To live among mountains is to witness their vitality, whether in the form of fresh rock falls, shifting riverbeds, or peaks that seem to inch closer to the clouds. Despite their movement, mountains remain symbols of permanence in human imagination. They anchor myths, religions, and cultures with their enduring forms. Yet to the geologist's eye, permanence is an illusion. These are not static monuments, but restless giants, engaged in an endless cycle of building and wearing away. To understand mountains is to recognize that their motion is not a rare occurrence. It is their very essence. When we look upon a great range and think it has always been there, unchanged and unmoving, we are witnessing only a single frame in a much longer film. Mountains are works in progress, shaped by forces that never cease. Their peaks rise as their slopes crumble, their valleys deepen as their summits climb, and their landscapes evolve even as they stand before us, seemingly timeless. They are the paradox of solidity and motion combined. This stillness of stone intertwined with the ceaseless churn of earth itself. Mountains are often imagined as unshakable fortresses, the immovable backdrop of the natural world. Yet even the tallest and most stoic peaks are not immune to collapse. Gravity, weather, ice, and fire all conspire against them, sometimes gently carving and reshaping, and sometimes unleashing sudden, violent change. When mountains fall, they remind us that the landscapes we admire for their permanence can, in a moment, become scenes of astonishing power and fragility. One of the most dramatic ways mountains give way is through landslides. These are the sudden downhill movements of rock, soil, and debris, pulled relentlessly by gravity. Sometimes a slope holds steady for centuries, appearing perfectly stable until a trigger sets it loose. Heavy rainfall can saturate soil and weaken the bonds holding a slope together. Earthquakes can rattle a mountainside until it cracks and slumps. Human activity, such as road building or deforestation, can also destabilize slopes that once held firm. The result is a cascade that can roar down with incredible speed, flattening forests, blocking rivers, and altering landscapes in a matter of minutes. The Himalayas, for instance, experience frequent landslides due to their steep slopes, heavy monsoon rains, and ongoing tectonic activity. In Nepal and northern India, entire villages have been buried under rushing waves of earth and rock. Farther west in the Alps, landslides sometimes block valleys, creating natural dams that later collapse and unleash devastating floods. What looks like the earth standing tall can, with the right nudge, become earth in motion. Avalanches share this sudden character but are composed not of rock and soil but of snow and ice. To the eye, a snow-covered slope may seem pristine and still, but beneath the surface, delicate layers of snowpack can conceal instability. Fresh snowfall resting on an older, icy base creates weak points where gravity can exploit the imbalance. A skier's movement, a loud noise, or even just the settling weight of new snow can trigger an avalanche. When it begins, it is unstoppable, a wall of snow that can move faster than a car on a motorway, sweeping away trees, boulders, and anything else in its path. Despite their danger, avalanches are also a natural part of mountain ecosystems. They clear old forests, create open meadows, and redistribute nutrients, making way for new growth. In this way, they're both destructive and regenerative, shaping alpine environments as much as they threaten human life and activity. The Swiss Alps, the Rockies, and the Himalayas all have long histories of avalanches, which local communities have learned to anticipate, respect, and sometimes even harness, by triggering controlled slides to prevent larger disasters later. Then there are volcanic eruptions, the most fiery and dramatic of mountain hazards. Unlike landslides or avalanches, which are driven mainly by surface conditions, volcanic eruptions erupt from deep within the planet. A volcano is a mountain built from fire, and its collapse or explosion can be among the most awe-inspiring events on Earth. Take Mount Vesuvius in Italy. In the year 79, it famously erupted and buried the Roman cities of Pompeii and Herculaneum under ash and pumice. Thousands of people were caught in the devastation, and yet their frozen remains also preserved a remarkable snapshot of Roman daily life. In more recent history, Mount St. Helens in Washington state provided a vivid example of how a mountain can literally fall apart. In 1980, an earthquake triggered a landslide that removed the northern flank of the volcano, followed immediately by a powerful eruption that blasted the mountain sideways. The once symmetrical cone was reshaped into a jagged crater, forever altering its profile. Not all eruptions are explosive. Some volcanoes, like those of Hawaii, release slow-moving lava flows that, while less immediately destructive, still transform the land. Lava buries forests, roads, and homes, creating new land even as it consumes the old. These eruptions remind us that mountains are not simply static monuments, but breathing features of a living planet. The hazards of falling mountains extend beyond these obvious examples. Rock falls, for instance, are smaller cousins of landslides, but no less dramatic in the moment. A single boulder breaking free can tumble with astonishing force, shattering whatever lies below. Frost plays a role here. Water seeps into cracks, freezes and expands, prying the rock apart until gravity finishes the job. In alpine regions, climbers are familiar with the sudden clatter of falling stones dislodged by thawing ice. These events are constant reminders of how dynamic steep terrain really is. Glacial outburst floods, sometimes called Jökullaups, are another way mountains unleash their stored energy. These occur when meltwater builds up beneath a glacier or behind an ice-dammed lake and suddenly bursts free. The result is a torrent of water capable of sweeping away bridges, forests and entire landscapes in a matter of hours. Iceland is famous for such events, as its combination of glaciers and volcanic activity makes for frequent and powerful Jökullaups. Although dramatic, these events are not merely disasters. They are part of the ongoing renewal of mountain landscapes. Avalanches clear paths for wildflowers. Landslides expose new rock faces that become colonized by plants, and volcanic eruptions create fertile soils that support lush ecosystems once the ash cools. What seems like destruction in the short term often becomes creation in the long run. Humans, however, live on very different timescales than mountains, and what is renewal over millennia can be catastrophe in a moment. This tension is part of why mountains hold such fascination. They are both magnificent and menacing, guardians of stability yet prone to sudden collapse. Communities that live near them often develop a profound respect for their unpredictability, creating myths, rituals, and practical systems to cope with their volatile nature. Modern science has helped in predicting and mitigating some of these hazards. Avalanche control involves studying snowpack layers, monitoring weather, and deliberately triggering small slides before conditions grow dangerous. Landslide risks can be reduced by monitoring rainfall, mapping unstable slopes, and avoiding construction in vulnerable areas. Volcanic eruptions can sometimes be forecast by studying gas emissions, seismic activity, and ground deformation. Despite these efforts, mountains maintain an element of surprise, their power never fully tamed by human understanding. When mountains fall, they remind us of Earth's restlessness. A slope that seems solid today may rush downward tomorrow. A tranquil snowfield may roar to life without warning. A serene volcano may suddenly erupt with fire from below. Each event is a reminder that mountains are not monuments carved once and left unchanged, but participants in the ongoing drama of our planet. To watch a mountain fall, whether through the slow crumble of erosion or the sudden violence of an avalanche or eruption, is to glimpse the energy stored in the very bones of the earth. These are moments when time, normally so patient in shaping landscapes, decides to act in an instant, and though they may be frightening, they also reveal the extraordinary vitality of a planet that is always in motion, always reshaping itself, and never truly at rest. A mountain may appear to be nothing more than a mass of rock and ice thrust skyward, but hidden within its slopes is a vast and intricate archive. Every ridge, every folded layer of stone carries with it the memory of ancient seas, vanished forests, and creatures long gone. To walk across a mountain is to stroll through chapters of Earth's story written not in ink, but in strata and fossilized remains. These towering forms are not just scenery, they are libraries of time. Consider the strata, those stacked layers of rock that form the bones of mountains. Each layer is like a page in a book, preserving a record of the environment at the time it was laid down. Millions of years ago, sediment settled at the bottom of the oceans and lakes, slowly compacting into limestone, shale, or sandstone. Later, tectonic forces bent and lifted these layers, carrying them high above sea level where they remain visible today. What was once sea floor may now be the summit of a peak. In the Himalayas, fossilized seashells have been found at altitudes of over 20,000 feet, proof that these colossal mountains were born from an ancient ocean floor shoved skyward by colliding plates. Fossils provide some of the most captivating evidence locked within these stony shelves. They tell stories not only of individual organisms but of entire ecosystems. A fern leaf pressed into slate reveals that lush forests once thrived where bare rock now dominates. A trilobite encased in limestone speaks of shallow seas swarming with life hundreds of millions of years ago. Ammonites, with their spiral shells, appear in abundance in mountain strata around the world, their shapes as intricate as any artist's design, testifying to the long reign of marine life before the rise of mammals. The Alps, for instance, are as much a museum as they are a mountain range. Fossils there reveal that much of the region was once covered by tropical seas. In the Rockies, layers of stone preserve evidence of enormous inland oceans and the creatures that swam within them. Even the mighty Andes hold clues in the form of corals, shells, and marine sediments, reminders that what now towers above clouds was once submerged. Mountains, it seems, are storytellers of profound transformations. Geologists read these stories through stratigraphy, the study of rock layers. Each stratum represents a moment in time, and by examining their sequence, scientists reconstruct ancient environments and the passage of eons. Horizontal beds of sandstone may indicate ancient deserts where wind piled dunes into towering forms. Layers of limestone might point to warm, shallow seas teeming with life. Shales, with their fine grains, could have formed in calm waters where tiny particles drifted to the bottom, burying and preserving whatever fell with them. Together these layers form a kind of diary of shifting climates, rising and falling seas, and the dance of life adapting to change. One of the most striking aspects of mountain geology is how it compresses vast spans of time into a single vista. In some ranges, you can see rocks that differ in age by hundreds of millions of years standing side by side, forced together by tectonic collisions. Imagine opening a book where the first and last chapters touch, with everything in between folded and crumpled. That is what mountains often are. Time bent into strange configurations, accessible to anyone willing to look closely. In Scotland, the Highlands preserve some of the oldest rocks in Europe, fragments of a continent that formed billions of years ago. Within those rugged stones are traces of primitive organisms, witnesses to the dawn of life. In contrast, younger mountains like the Rockies and Himalayas contain fossils from relatively recent epochs, including evidence of the Ice Age megafauna that once roamed their valleys. Each range offers a different window into Earth's timeline, and together they provide a patchwork of the planet's grand narrative. The fossilized remains within mountains are not limited to seashells or plants. Entire skeletons have emerged from mountain strata. In the Andes, fossils of giant marine reptiles such as ichthyosaurs have been uncovered at dizzying elevations, demonstrating that these ridges were once oceanic realms. In the Rocky Mountains of North America, dinosaur bones have been revealed as erosion stripped away overlying rock. To discover a fossil in such a place is to hold a piece of deep time in your hands, to touch a story that predates humanity by millions of years. Mountains also reveal the cycles of Earth's climate. Within their rocks lie clues of ice ages, warm tropical periods and catastrophic extinctions. Layers rich in coal suggest ancient swampy forests that trapped carbon and influenced global climate. Bands of glacial deposits in high mountain areas point to times when ice stretched far beyond its modern limits. Even volcanic ash preserved in stone tells of eruptions that altered skies and temperatures, leaving fingerprints that geologists can match to events long past. For scientists, mountains are like vast research libraries where every stone can be studied. But for anyone, even without a background in geology, there is wonder in knowing that beneath your boots lies the record of Earth's evolution. To touch a fossilized shell at high elevation is to imagine the waves that once washed over it. To trace a ripple-marked slab of sandstone is to picture wind or water shaping it in a forgotten landscape. These moments connect us across time, shrinking the gulf between the present and the distant past. What makes mountains so fascinating as historical records is that they are both archives and editors. They preserve fossils and strata with exquisite detail, yet they also fold, break and scatter them. A fossil may lie upside down, thrust high above sea level, or split by a fault line. Strata may be twisted into curves that defy their original horizontality. It is as if the planet has written its history in clear lines, then scribbled across the pages, challenging us to decipher what remains. This duality makes mountain geology both a puzzle and a treasure. Scientists must learn to read not only what is present, but also what has been erased or distorted. Yet the challenge itself reveals more about the Earth, its relentless movement, its capacity for renewal, and its refusal to remain static. In this way, mountains embody the paradox of permanence and impermanence, guardians of memory that are themselves always changing. When you look at a mountain, you're not just looking at a peak of stone, you're gazing into a monument of time. Fossils and strata reveal that what appears eternal is, in fact, a living record of transformation. Mountains are time travelers in stone, carrying seashells to the clouds, preserving forests in slate, and holding the bones of giants in their hearts. They remind us that the world we know is only one frame in a much larger story, and that by reading the rocks we can glimpse the countless worlds that came before. There is something awe-inspiring about numbers that strain the imagination, and few statistics stretch human perspective quite like the heights of the world's tallest peaks. Mountains already feel immense when viewed from a valley floor, yet some reach such staggering elevations that they seem to scrape the ceiling of the sky. These summits are more than high points on a map. They are benchmarks of endurance, symbols of exploration, and reminders of just how small human beings are against the backdrop of Earth's scale. At the crown of them all stands Mount Everest, the colossal sentinel of the Himalayas. Its peak rises to about 29,000 feet above sea level, which is nearly the cruising altitude of a modern jetliner. To put that into perspective, if you were seated by a plane window gazing down at the world below, Everest's summit would nearly brush your wingtip. At that altitude, the air holds only about 1/3 of the oxygen available at sea level, making every breath feel like sipping air through a thin straw. Yet there it stands, the loftiest place on land, born of continents colliding and still inching higher with each passing year. Everest may hold the title, but its neighbour to the northwest, K2, is often called the Mountaineer's Mountain. It does not quite match Everest's height, standing around 28,200 feet, but in reputation it often looms even larger. The shape of K2 is more unforgiving, a pyramid of rock and ice that seems almost deliberately designed to repel climbers. Where Everest has been summited by thousands, K2 has seen far fewer successful ascents, and its slopes have earned a fearsome reputation for avalanches, storms, and technical difficulty. Some have described it as beautiful but merciless, a mountain that demands respect and punishes any lapse. North America boasts its own giant in Denali, formerly known as Mount McKinley, which rises over 20,000 feet above sea level in Alaska. Though shorter on paper than the Himalayan titans, Denali is arguably more imposing when measured from base to summit. Its vertical relief is greater than Everest's, because it thrusts up dramatically from relatively low surrounding terrain. Imagine standing in a flat landscape and seeing a peak rise almost 4 miles straight upward. That is the scale of Denali. For indigenous peoples of Alaska, the Koyukon Athabascans, the mountain has long held spiritual meaning, its name Denali translating to the High One. In South America, the Andes cradle Aconcagua, the tallest mountain outside Asia. Its summit reaches nearly 23,000 feet, a snow-capped monarch towering over Argentina's Mendoza province. Unlike the sheer ice walls of K2 or the windswept ridges of Denali, Aconcagua offers climbers a less technical, though still demanding path to the top. Yet even with its more gradual slopes, the lack of oxygen at such heights makes the climb a trial of endurance. Standing on Aconcagua's peak, one is closer to the stars than anywhere else in the southern hemisphere. Numbers alone can be difficult to grasp, so comparisons help anchor these titans in daily experience. Everest is over 3 times taller than the Grand Canyon is deep. Denali is taller than 20 Eiffel Towers stacked one atop the other. Aconcagua dwarfs even the tallest skyscrapers, and K2 towers above the world's highest cities, as if they were nestled at its feet. The sheer verticality of these mountains makes them unlike anything else in the human environment. Giants among giants, where altitude rewrites the rules of both physics and physiology. Climbers who approach these heights quickly discover how different life becomes near the top of the world. At elevations above 26,000 feet, often called the death zone, oxygen levels are so low that the human body struggles to survive. Simple actions like tying a bootlace can leave one gasping for breath. Water boils at lower temperatures, making it harder to stay warm. Weather can shift in minutes from calm skies to hurricane-force winds. It is in this realm that Everest and K2 command their grim reputations, reminding all who venture there that mountains set their own terms. Yet these giants are not only challenges for climbers, they're also critical features of Earth's geography. Everest and the Himalayas are still rising today as the Indian plate presses northward into Asia, creating not just towering peaks but also monsoons and climate patterns that affect billions of people. Denali shapes local weather in Alaska, forcing moist air to rise and drop heavy snowfall on its slopes. Aconcagua, standing tall in the Andes, influences the rivers and agriculture of Argentina, feeding vineyards that thrive in its rain shadow. These mountains are not isolated monuments, they're active participants in the systems that sustain life. Each also carries cultural weight. Everest is known as Sagarmatha in Nepal, forehead of the sky, and as Chomolungma in Tibet, goddess mother of the world. K2, lacking a local name when Western surveyors labelled it in the 19th century, retains its stark alphanumeric identity, which somehow fits its austere and forbidding personality. Denali has been revered by Alaska natives for centuries, long before it was renamed by outsiders, and its restored name represents not only geographic grandeur but cultural respect. Aconcagua, whose name is thought to derive from the Quechua phrase stone sentinel, stands as a guardian over South America's highest ridge. When gazing at photographs of these peaks, it is tempting to see them as isolated points reaching into the heavens. But in reality, they are the crown jewels of immense ranges, connected to valleys, glaciers and rivers. Everest is only the highest of many Himalayan summits, dozens of which surpass 25,000 feet. K2 belongs to the Karakoram Range, a fortress of jagged peaks. Denali anchors the Alaska Range, while Aconcagua reigns over the Andes, the world's longest continental mountain chain. Each is both an individual marvel and part of a far larger tapestry of stone and ice. The scale of these mountains resists easy comprehension. Imagine standing at their bases and looking upward. The summit would not appear as a gentle rise, but as an overwhelming wall of earth. Even from afar they dominate horizons, dictating the shape of clouds and the flow of rivers. In their presence, human concerns feel small, fleeting, almost whispered. They embody endurance, their bulk reminding us of forces that have shaped the Earth over millions of years. Everest, K2, Denali and Aconcagua represent the pinnacle of the planet's vertical landscape, each unique in character yet united in grandeur. They remind us that the Earth is not a flat, predictable stage, but a world of extremes, where stone reaches upward in defiance of gravity and atmosphere, thins to the point of breathlessness. To measure them is to measure against the limits of human imagination, and to stand before them is to feel the humbling scale of nature itself. Mountains seem eternal when viewed from a valley floor, their ridges etched against the horizon like immovable guardians. Yet even the most imposing peaks are temporary features in Earth's story. Given enough time, every mountain succumbs to the quiet work of wind, water, ice and gravity. Though they rise with immense drama, their decline is subtle, stretching over millions of years. It is a reminder that landscapes are not fixed paintings but living canvases, always being reworked by the hand of geology. Consider the Appalachians of eastern North America. Today they roll like a long green spine of forested ridges and rounded summits. But if we rewind the clock 300 million years, these hills were jagged, towering peaks, rivaling the Himalayas in height. Plate collisions during the assembly of the supercontinent Pangaea thrust them skyward. Since then, rain and rivers have carried away their sharpness grain by grain, transporting ancient mountaintops downstream to build coastal plains. The result is a landscape where the ghosts of once great peaks linger in softened forms, a record of relentless erosion. This fate awaits every mountain range. The Rockies, the Alps, the Andes, all will in time be reduced to subdued hills and broad flatlands. Rivers carve valleys, glaciers scrape cirques and troughs, and frost shatters cliffs into rubble. Even the Himalayas, still surging upward as India presses into Asia, cannot escape. For now, their rate of uplift outpaces erosion, keeping them lofty, but eventually tectonic vigour will wane. Once it does, water will dominate, chiselling Everest and its neighbours into gentler landscapes, their grandeur carried off as sand and silt to distant seas. Yet while some ranges wear down, new ones are destined to take their place. Earth's crust is restless, and tectonic plates are forever drifting. In the far future, the Atlantic Ocean may shrink as the Americas inch back toward Europe and Africa, potentially closing with a collision that would give rise to new mountains. In East Africa today, the crust is slowly pulling apart, stretching and cracking to form the Great Rift Valley. Over millions of years, this process may create a new ocean, with volcanic mountains standing along its edges, reshaping the continent itself. The Mediterranean provides another glimpse of geologic change. The slow convergence of the African and Eurasian plates continues to buckle land, giving rise to the Alps, the Apennines, and the Atlas Mountains. These ranges are still young in geological terms, full of rugged peaks and active faults. As Africa continues its northward drift, more collisions are likely, ensuring that mountain building remains a key theme in the region's story. It is tempting to think of erosion as destruction, but it is also a form of recycling. The sediments worn from mountains feed fertile plains and deltas. The silt of the Mississippi, for example, began as fragments of the Rockies carried by rivers across the continent. The sands of beaches once belonged to peaks, liberated by frost and rain. In this way, the slow dismantling of highlands gives life to new environments, enriching soils and feeding ecosystems far from their stony origins. Mountains also act as timekeepers, marking the balance between uplift and erosion. If the tectonic push below exceeds the wearing power of air and water above, peaks grow taller. If weathering outpaces uplift, they decline. Over geological timescales, this dance ensures that no summit lasts forever. The tallest ranges of today will be reduced to stumps, while fresh forces will sculpt new giants elsewhere. Earth's surface is never static, but a rolling cycle of rise and fall. Imagine travelling tens of millions of years into the future. The Himalayas may be worn into rounded remnants, their once famous summits lost to rivers and plains. New chains could tower in regions we do not associate with mountains today, perhaps where continents collide anew. Meanwhile, the remnants of today's ranges might stand as subtle uplands, their grandeur hinted at only by the stubborn presence of resistant rocks jutting above surrounding fields. Even islands tell this story of change. The Hawaiian chain, born of a volcanic hotspot, grows new peaks, even as older ones sink back into the sea. Mauna Kea, which rises over 33,000 feet from its oceanic base, will one day erode and subside, while fresh volcanoes continue to build on the seafloor to the northwest. In the grand arc of time, the Pacific is littered with drowned volcanoes, called seamounts, that once breached the surface as islands but have long since returned to the deep. All of this speaks to the cyclical rhythm of geology. Mountains are born from collisions or volcanic fire, They stand proud for millions of years, and then they are slowly worn away. Their remnants enrich new land, and fresh forces beneath the crust raise successors to replace them. What seems unchanging on human timescales is, in truth, only a single verse in Earth's long geological song. Mountains, then, are not eternal monuments but chapters. Each ridge, each peak, each valley is part of a narrative that loops endlessly. Uplift, erosion, deposition, and renewal. The cycle is vast enough that no single generation of people will see its full arc, but by studying ancient ranges alongside youthful ones, the story reveals itself. The rounded Appalachians and jagged Himalayas are not opposites, but points along the same continuum. To contemplate this is both humbling and reassuring. Peaks that feel timeless will one day be gone, but they will not vanish without leaving gifts: fertile soils, flowing rivers, new plains upon which life can flourish. And while they fade, others will rise, pushed upward by the same deep forces that have shaped Earth since its beginning. The world's surface is a theatre of constant change, sculpted by time itself. In the long view, mountains are both fleeting and eternal. No single summit endures forever, but the cycle of mountain making never ceases. There will always be new horizons, new ridges, new giants born of the Earth's restless crust. What we see today are simply the peaks of this age, standing tall for now, destined one day to crumble, yet ensuring that the story of mountains will never truly end. Mountains do not simply stand as stone monuments. They breathe life into the air around them, bending winds, catching clouds, and deciding who gets drenched in rain and who waits in parched silence. In many ways, these great ridges and peaks are among the most influential architects of climate on Earth. Without them, weather patterns would be far less dramatic, and in some places life as we know it could not exist. Picture warm, moist air drifting inland from the ocean. When it meets a mountain range, it cannot continue in a straight line. Forced to rise, the air cools as it climbs, and its invisible moisture condenses into clouds. Those clouds release their burden as rain or snow, soaking the windward slopes. This process is known as orographic precipitation, and it explains why lush forests cling to the sides of mountains that face the sea. In contrast, the far side of the same range often lies in what is called a rain shadow, where the descending air is dry, leaving valleys and plateaus arid. The Sierra Nevada in California demonstrates this beautifully. On the western slopes, giant sequoias and thick forests thrive, but to the east, the rain shadow creates the arid expanse of Death Valley. The Himalayas hold another role of astonishing scale. Acting like a colossal barrier between South Asia and the interior of Asia, they shape the very monsoons that sustain billions of people. Each summer, warm, moisture-laden winds sweep northward from the Indian Ocean. When they strike the Himalayas, the mountains force this air upward, triggering torrential rains across India, Nepal, and Bangladesh. These seasonal downpours feed rivers like the Ganges and Brahmaputra, replenishing farmlands that depend on their floods. Without the Himalayas, the monsoon as we know it would not exist, and the lives of entire civilizations would be reshaped. Mountains also nurture glaciers, which are themselves climate machines. High altitudes bring cold, and snow that falls year after year compacts into thick rivers of ice. These frozen giants not only carve valleys but also act as water banks for downstream communities. During warm seasons, melting ice feeds rivers that would otherwise run dry. The Andes, for example, hold tropical glaciers that provide water for millions of people living in Peru, Bolivia, and Ecuador. When climate shifts and glaciers shrink, it is not only the mountain that changes, but also the human settlements that depend on its frozen reserves. Glaciers influence global systems as well. They reflect sunlight with their bright surfaces, cooling the planet slightly. When glaciers retreat, darker ground is revealed, which absorbs more heat, creating a feedback loop that can accelerate warming. This interplay between ice and atmosphere makes mountains not just local climate controllers, but also participants in Earth's broader balance. Beyond their icy summits, mountains affect the winds themselves. Air currents twist and flow around ridges, creating eddies and turbulent zones that can stretch for hundreds of miles. Pilots know this well, as flying near mountain ranges often means encountering sudden shifts in air pressure and strong gusts. For the atmosphere, mountains are obstacles that add texture, redirecting circulation patterns on both regional and global scales. Take Central Asia, for instance. The vast Tibetan Plateau, often called the roof of the world, plays a decisive role in shaping weather not only in Asia, but across the Northern Hemisphere. Its high surface acts like a hot plate in summer, heating the air above it, which in turn influences jet streams and the strength of the monsoon. In winter, the plateau cools dramatically, setting up pressure differences that affect winds across thousands of miles. Few landforms exert such reach, making this elevated landmass one of the most powerful climatic actors on the planet. Mountains also serve as natural laboratories, where small shifts in climate become magnified. A few hundred meters of altitude can mean entirely different ecosystems, from temperate forests to alpine meadows to bare, icy rock. This steep layering of environments means that as global temperatures rise, plants and animals must either move upslope to cooler habitats or face decline. In effect, mountains are like vertical climate gradients, and they reveal changes in ways that flatter landscapes cannot. When glaciers retreat, when tree lines climb higher, when snowpacks arrive later and melt earlier, mountains record the story of a warming world with striking clarity. The interplay of mountains and climate even extends to deserts far away. The Andes, for instance, create the Atacama Desert in Chile by blocking moist air from the Amazon basin, while also catching the cool, dry influence of the Humboldt Current offshore. This double effect produces one of the driest places on Earth, where some regions go centuries without significant rain. Without the Andes, the west coast of South America would look entirely different, shaped by lush greenery rather than barren salt flats. In North America, the Rocky Mountains play a similar role, redirecting storms and creating sharp contrasts in climate. Their eastern flanks often experience Chinook winds, warm, dry gusts that descend after crossing snowy peaks, sometimes raising temperatures by dozens of degrees in mere hours. Such sudden thaws can feel almost magical, but are born from the physics of air expanding and warming as it sinks. These phenomena remind us that mountains are not passive features, but active players in atmospheric dynamics. Even oceans feel the influence of mountains, though in an indirect way. The vast stores of fresh water locked in glaciers and snowpacks eventually flow to the sea, contributing to sea levels. In periods of glaciation, when mountains are capped with larger ice masses, sea levels drop, exposing land bridges and reshaping coastlines. When ice retreats, seas rise again. These fluctuations have repeatedly influenced migration patterns of humans and animals alike, linking mountain climates to the ebb and flow of life across continents. The beauty of mountains' role in climate is their duality. They can nurture life by capturing water and feeding rivers, yet they can also create deserts by casting long-range shadows. They can cool the world with their glaciers, or hasten warming when those glaciers vanish. They bring rains essential to crops, but they also unleash floods when storms are intensified against their slopes. In every case, mountains amplify and redirect the atmosphere's energy, creating a world of contrasts. To stand in the presence of a mountain is to witness more than rock and ice. It is to feel the invisible currents of air reshaped, the cycles of water decided, and the pulse of global climate altered by stone spires that stretch into the sky. Mountains hold sway not only over landscapes but over the very systems that make Earth habitable. They are reminders that even the most solid-seeming places are, in truth, central to the fluid, ever-changing breath of the planet. There is something about mountains that stirs the human spirit in a way few other landscapes can. Oceans are vast and mysterious. Forests are deep and sheltering, but mountains stand as guardians, tall, silent, and seemingly eternal. For as long as people have looked upward, peaks have captured imagination, reverence, and longing. They are more than stone. They are symbols of permanence, challenge, and serenity, written into the fabric of cultures across the world. Part of the pull comes from sheer scale. A mountain makes one feel small in the most humbling sense. To stand at its base is to be reminded of time beyond comprehension, millions of years of uplift, erosion, and renewal embodied in a single ridge. Humans measure lives in decades, perhaps a century if fortune smiles, but mountains endure long enough to watch continents drift. In this endurance lies their symbolism, permanence in a fleeting world. They are the counterweight to human frailty, solid forms against the ephemeral rush of existence. At the same time, mountains have always been associated with striving upward. A summit calls to something primal. To climb is to test limits, both physical and spiritual. The peak may be far out of reach, but the effort itself is meaningful. That is why so many traditions describe mountains as ladders to the divine. Mount Sinai, Mount Olympus, Mount Fuji, Kailash, each carries stories of gods, revelations, and sacred encounters. The height of a mountain creates a natural metaphor for transcendence, the notion that to go higher is to come closer to truth or enlightenment. But mountains are not only revered as spiritual gateways, they also embody challenge in its purest form. The effort required to cross a pass or to scale a sheer face strips life down to its essentials: endurance, patience, and courage. Confronting a mountain has often been likened to confronting oneself. Every step upward is both a victory against gravity and an internal reckoning. Why endure thin air, cold winds, and aching muscles? Because the mountain offers no easy answers, only the test itself. And yet that very struggle explains the deep satisfaction climbers feel when they reach the top. The summit is not simply a patch of ground, it is proof of persistence. Yet mountains are not only symbols of trial, they also embody serenity, a stillness found in few other places. High valleys and alpine meadows invite quiet reflection, where streams sparkle in thin sunlight and the air carries only the calls of birds or the whisper of wind. In such places, time feels suspended. Even the modern mind, restless with demands and distractions, softens in the presence of peaks. The slow rhythm of weathering stone and drifting clouds soothes the spirit. It is perhaps no accident that poets and thinkers often retreated to mountains when seeking clarity. In their stillness lies a kind of wisdom, that not everything must be hurried, that endurance is its own beauty. Philosophers have long been drawn to the symbolism of mountains. Friedrich Nietzsche wrote of peaks as metaphors for self-overcoming, while the Romantics saw them as places where the sublime could be experienced. Beauty so immense that it inspires awe tinged with fear. In Eastern traditions, mountains are often seen as embodiments of harmony, immovable yet shaped by wind and water, serene yet alive with energy. Across cultures, the message resonates. Mountains mirror the human search for meaning, reflecting both struggle and peace. Their symbolic weight also comes from their role as thresholds. To cross a mountain range often meant entering another world. Ancient travellers knew that beyond the pass, languages, customs, and landscapes might be entirely different. Mountains thus came to represent boundaries, not only of geography but of perception. They stand as reminders that new perspectives often require effort, that insight comes from climbing, from leaving the familiar behind and accepting the challenge of ascent. On another level, mountains remind humans of their limits. However strong, however ambitious, people are temporary visitors in such places. Storms, avalanches, and rockfalls make clear that nature is not to be subdued but respected. The humility they enforce is philosophical in itself, a lesson in balance between ambition and reverence. To revere mountains is to accept that some things lie beyond control, and that is not a failing but a truth to live with. The draw of mountains may also come from their contrast to daily life. Valleys and plains are where cities grow, where fields are ploughed, where ordinary life unfolds. Mountains, by contrast, rise above, aloof and apart. They create distance from the mundane. To journey into them is to step into a realm that feels outside of time, a place where human concerns shrink in importance. Perhaps this is why mountains often figure in stories of vision quests, pilgrimages and revelations. Their very geography demands departure from routine, creating space for reflection and transformation. And then there is the simple beauty of form. Snow-draped summits glowing at dawn, ridgelines etched in silhouette, rock faces catching the last light of sunset. These sights stir emotions that words often fail to capture. Their geometry is both rugged and graceful, at once raw and harmonious. Looking upon a mountain awakens the sense that the world holds more than function. It holds majesty. That aesthetic pull is philosophical in its own way, reminding humans that existence is not only about survival, but also about wonder. The permanence of mountains is, of course, an illusion. They are worn down, reshaped, and eventually erased by time, but perhaps that deepens their symbolic role. Even stone giants must bow to the patience of wind and rain. In that truth lies a paradox. Mountains feel eternal, yet they too are impermanent. They embody the dance between endurance and change, between stability and flux. To contemplate them is to contemplate life itself. Brief, fragile, yet part of something that continues beyond individual measure. In the end, the philosophy of mountains is not a single idea, but a constellation. They are teachers of humility, symbols of striving, sanctuaries of peace, and reminders of impermanence. They call people upward, outward, and inward all at once. When gazing upon a peak, one is not only seeing stone, but also glimpsing the layers of meaning that generations have poured into them. Perhaps that is why the human heart returns to them again and again. Whether as obstacles, sanctuaries, or symbols, mountains remain companions in thought and spirit. They remind us that while we are small, we are capable of seeking, of climbing, of pausing to breathe in the thin air of higher ground. In their presence, people remember both their limitations and their potential. Mountains do not speak, but they teach, quietly, steadily, and always in stone. From the moment the earth cooled enough to form a solid crust, the story of mountains has been unfolding. They are the punctuation marks in the planet's long narrative, rising from restless forces beneath our feet, growing toward the sky, and eventually softening with age until they're carried away grain by grain. To trace the life of a mountain is to trace the patient rhythm of the earth itself. Mountains begin in fire and pressure, in the hidden collisions of continents and the slow shifting of plates. Deep inside, molten rock stirs and flows, pushing upward until it breaks the surface as volcanoes or folds stone into vast ranges that arch across the horizon. What to human eyes appears sudden, a jagged peak piercing the clouds, a rumbling eruption building a cone of ash and lava, is only the briefest flicker in geological time. In truth, mountain birth is an act of unimaginable patience, a sculpting measured not in centuries but in millions of years. Once raised, mountains live lives as varied and dramatic as any creature. They host glaciers that carve valleys, rivers that slice through their bones, and winds that polish their faces. They divide climates, catching storms on one side and casting shadows of dryness on the other. They create habitats that shift with height, lush forests at their feet, alpine meadows in their middle slopes, and icy summits where only the hardiest life can endure. In this way, mountains are not passive monuments of stone, but active participants in the web of life, shaping ecosystems and influencing the rhythm of weather. Their youth is sharp and bold, young ranges like the Himalayas thrust into the sky, their peaks jagged and raw, still rising even now as tectonic plates press against one another. These are mountains full of energy, where landslides and avalanches testify to their restless growth. As time passes, they mellow. Erosion rounds their edges, glaciers retreat, and rivers carry away their fragments to the sea. What were once towering giants gradually transform into subdued ridges, gentle highlands or rolling hills. The Appalachians and the Scottish Highlands remind us of this quiet aging process. Once as mighty as the Himalayas, they now wear their years gracefully, softened by eons of weather and time. But even as mountains decline, the earth is never finished. New ones will rise as old ones fade. Subduction zones continue to brew fiery arcs of volcanoes. Continental collisions will one day create new summits, just as ancient seas once gave birth to today's ranges. The cycle is endless. Mountains are born, they live, they crumble, and their materials return to the deep earth, ready to be raised again. It is a reminder that nothing in nature is truly permanent, not even the stone giants that seem unshakable. And yet, in human time, mountains are permanent. They are there for countless generations, standing watch as civilizations rise and fall, as cultures bloom and fade. A child gazes at a peak and grows old beneath its shadow, and still it remains. A village may stand at its base for 1,000 years, and the mountain will endure long after. To us they are eternal presences, companions in the story of humanity. There is a lesson in that endurance. Mountains teach patience. They show that the greatest changes happen slowly, almost invisibly, and yet with certainty. Just as stone becomes sand, just as glaciers carve valleys, our own lives are part of a longer flow of time. Mountains remind us that stillness and motion are not opposites, but partners. Even what appears motionless is always in the process of becoming something else. They also remind us of humility. To look upon a mountain is to be reminded of scale, of how small human concerns are beside ridges that have stood for millions of years. And yet, rather than diminish us, this humility can comfort. It is a relief to know that not everything bends to human will, that there are guardians of the landscape who endure beyond our reach. Mountains stand above, unbothered by haste, offering a sense of permanence in a fleeting world. And perhaps most of all, mountains inspire. Their presence draws the gaze upward, suggesting possibility, resilience, and serenity all at once. They have served as sacred places, as challenges to climb, as shelters for wildlife, as sources of rivers that sustain life far beyond their slopes. They are symbols not only of endurance, but of beauty, of the Earth's ability to create forms so grand that they stir both awe and peace in equal measure. As the story of mountains continues, they will keep rising and falling, appearing and vanishing in spans of time far beyond human reckoning. Yet for us, they will always remain what they have been for countless generations. Steadfast companions, teachers of patience, keepers of silence. They will always stand on the horizon, reminding us of time's slow work and of the beauty found in endurance. And so, when the day fades and shadows stretch across their slopes, mountains are there, still, watchful, unhurried. They have seen ages pass and will see ages still to come. Whatever changes sweep across the world, the mountains will continue to keep their quiet vigil, serene in their grandeur, eternal in human memory. They are not only stone and snow, but symbols of permanence and peace. They are the Earth's way of reminding us to pause, to breathe, and to remember that in the long rhythm of time, mountains will always be there, watching over us.